In a constantly evolving world where technology advances at an incredible speed and global challenges demand urgent solutions, one thing remains fundamental: measurement. From protecting public health to ensuring fair trade and promoting scientific discoveries, precise and reliable measurements shape our world. But this would not be possible without a bold action taken 150 years ago. Faced with a multitude of different measurement systems that hindered trade, scientific progress, and industrial development, the world recognized the need for a unified approach. So, in 1875, 17 states came together to establish a common solution: the Metre Convention. Laying the foundations for international collaboration in metrology and ensuring the accuracy, comparability, and uniformity of measurements world over. Since then, our shared journey has been marked by several key milestones. We sanctioned the international prototypes of the metre and the kilogram. We adopted the international system of units. We officially approved the use of coordinated universal time, defined the metre based on the speed of light, and in 2019, we redefined SI units based on constants describing the natural world. At every step, our community's driven progress that impacts all aspects of modern life. Today, as we enter a new era, advances in digital transformation and quantum technology and metrology will enable greater precision, enhanced automation, and better data integration across scientific disciplines. They will empower industries to innovate and tackle emerging global challenges with greater confidence. Together, we have built a legacy, and together, we will continue to shape the future of measurement. That was my voice. Welcome, everybody. Ladies, gentlemen, distinguished guests, your excellencies, good morning and welcome to the World Metrology Day Symposium, marking 150 years of the Metre Convention: science, innovation, and global impact. I'd like to think that one of the reasons why I was invited to join you is because my name is Georgia Kelvin Smith. It's actually Calvin Smith, but that's enough of a bridge for me. But it is really such an honor to be here amongst you as we all gather together to celebrate such a historic milestone, not only for the global scientific community, but for most people. As to my layman's delight, I have had the privilege of discovering amidst some of the really passionate conversations I've had in preparation for today. And from what I've learned, it has been quite a ride. For a century and a half, from the mundane to the mind-blowing, the Metre Convention has driven human progress across the board, demonstrating the power of international metrological cooperation in ensuring that the systems of measurement that underpin our societies are precise, reliable, and unified across borders. So we're here today to appreciate this extraordinary legacy, but also to take stock and look ahead to the innovation and collaboration that will be needed to drive human progress and shape where we go over the next 150 years of the world's scientific and social advancement. So we have a really interesting and exciting day ahead. Thank you to all of the amazing speakers and panelists whose work and wisdom has enriched metrology over the years and who are also here generously to share of their insight and understanding. And of course, a huge thank you from UNESCO to dedicated partner, the Bureau International de Poids et Mesures, because besides the BIPM's monumental support for this event, it's also been the vehicle for the Metre Convention's purpose since the very beginning. So we very literally could not have done any of this without you. Thank you. So, What is celebration without music? Another thank you in advance. Merci au Malick Dio Band. Malick Dio est un musicien sénégalais basé ici à Paris.
I'd like to thank the Malick Dio Band. This is a Senegalese band. They are based in Paris. We are very, very lucky. We are going to hear him with Abdou Koyate, who is from Casamance. Thank you very much to you both. Thank you for the music.
For anyone who needs it, English will be on channel 1 and French will be on channel 3. Alors que nous entrons.
As we start this very important day, I would like to suggest that you participate actively and seek inspiration in this day. Let us together celebrate these accomplishments and let us together continue building a future that's based on scientific excellence that's shared by all. Thank you all, and now I have the honor to give the floor to Xiaofeng Hu, who is Director of the Division of Science Policy and Basic Sciences from the Natural Sciences sector at UNESCO. You have the floor, sir, for your speech.
Excellencies, dear esteemed colleagues, valued friends of metrology and sustainable development, ladies and gentlemen, good morning. It is my profound honor to welcome you to UNESCO on this historical occasion as we celebrate World Metrology Day. This year's celebration carries special significance, marking the 150 years anniversary of the Metre Convention. To commemorate these milestones, we are organizing a symposium under the theme 150 Years of Metre Convention, Science, Innovation, and Global Impact. Today, we gather to honor a global framework that has not only revolutionized measurement science, but also enabled unprecedented international cooperation for human progress. Ladies and gentlemen, metrology is far more than a technical field. It is the foundation of trust, resilience, and collective progress. It enables us to ask a fundamental question, building with confidence, treat with fairness, and confront global challenge with precision. From pioneering medical breakthrough to deploying sustainable technologies, internationally recognized measurement are what bridge scientific discovery with tangible, life-changing impact. Let us reflect on one of the most remarkable engineering achievements in human history, the construction of the Great Pyramid over 4,000 years ago. Astonishingly, without modern instrument, its base form a near-perfect square with less than 1% deviation. This architecture marvel was achieved through standardized measurement tools, demonstrating that even in the ancient civilizations recognized the profound power of precision. Centuries later, in Enlightenment era France, hundreds of conflicting measurement systems created commercial chaos and social discord. The revolutionary solution emerged as a metric system, more than just a scientific advancement, but a societal transformation that really culminated in the historic 1875 Metre Convention. This foundational agreement established the universal measurement framework that remains indispensable to our modern world. The 150th anniversary of the Metre Convention stands as a testament of the enduring strength of the international scientific collaboration, what began with 17 signatories, has blossomed into a dynamic global partnership grounded in shared standard and mutual trust. Milestones like the establishment of the International System of Unit and the recent redefinition of fundamental unit using universal constant highlight metrology's dynamic evolution and its deep synergy with scientific progress. This year, the theme, Science, Innovation, and Global Impact, honor our legacy of achievement while inspiring shared vision for the future. In an era defined by interconnected challenges, consistent and credible measurement across borders has become a cornerstone of progress. That is why in 2023, UNESCO General Conference unanimously designated May 20 as World Metrology Day, a landmark decision that formally acknowledged metrology's indispensable role in advancing peace, sustainable development, and global prosperity. Today, as we commemorate the second official celebration of this occasion, we are honored to convene in Paris, the historical home of the Metre Convention, where international metrology cooperation began. As we look ahead, UNESCO's flagship scientific initiative continue to highlight the fundamental role of measurement science. The International Decade of Sciences for Sustainable Development and UNESCO's leadership calls for strengthened global scientific collaboration to realize SDGs. In this vital mission, metrology serves as a cornerstone, ensuring data integrity, enabling evidence-based policy making, and fostering equitable innovation worldwide. Moreover, the International Year of the Quantum Science and Technology highlights the transformative potential of frontier research. In this context, quantum metrology is emerging as a new frontier, providing ultra-precise tools for timekeeping, navigation, environmental sensing, and beyond. These developments not only represent scientific victory, but they also further UNESCO's mission to democratize access to knowledge and empower all nations through science. I wish to express our deepest appreciation to the International Bureau of Weights and Measures, our valued partner in hosting this celebration. Thanks. We equally recognize the dedicated effort of the global metrology communities, including national metrology institutes, recognized regional organizations, legal metrology authorities, and countless experts worldwide, whose tireless work maintains measurement systems that are accurate, responsive, and equitable for all. Ladies and gentlemen, as we celebrate the 150 years anniversary of the Metre Convention, let us reaffirm our collective commitment to uphold scientific integrity, to strengthen global cooperation, and to ensure that measurement continue to serve as the bridge between innovation and inclusive, sustainable progress. Thank you.
Thank you so much, Mr. Xiaofeng Hu. And now, for someone from a nation that has been a huge support in spotlighting the work of BIPM and the importance of metrology. It was Kazakhstan that officially proposed the recognition of World Metrology Day to the UNESCO General Assembly, leading to its launch for the first time last year on May 20th. So it's a great honor to hand you over to His Excellency, Mr. Asghar Abdrakhmanov, the Ambassador, Permanent Delegate for Kazakhstan to UNESCO. Ambassador, thank you very much. Please join me on stage.
everybody. Good morning, bonjour, khairul kun. Happy Metrology Day, World Metrology Day. I am happy to be here, to find myself here with all of you today on this momentous jubilee. When we started back in 2019, the initiative to give the World Metrology Day the UN status, the status that it fully deserves. We could only imagine what it would be the 150th anniversary of the Metre Convention. And today, we are here in the packed main room of the main UN agency for culture, education, information, and yes, science. We are here to celebrate the anniversary of what is arguably the oldest intergovernmental agreement in force and the oldest intergovernmental organization in existence. So on this day, I am privileged to deliver to you the message from the Minister of Trade and Industry of the Republic of Kazakhstan, who himself is a metrologist, Mr. Arman Shakkaliyev, who unfortunately could not join us in person, but asked to send his warmest greetings to all his colleagues. So let me deliver this. Dear Dr. Vinant Löw, President of the International Committee for Weights and Measures. Dear Dr. Martin Milton, Director of the International Bureau of Weights and Measures. Dear Dr. Hu Shaofeng, Excellencies, distinguished delegates, scientists, metrologists, students, ladies and gentlemen. I want to thank you all for coming together from around the world to celebrate the 150th anniversary of the signing of the Metre Convention, a historic treaty that laid the foundation for the global measurement system we rely on today. You gather not only as representatives of your countries, but as stewards of shared future, a future where measurement science is not merely a tool of precision, but a bridge for collaboration, trust, and innovation across nearly every aspect of life. On this day, I sincerely regret that I cannot join you on this momentous occasion, but I believe that during this symposium there will be meaningful discussions that span a wide range of topics, from the legacy of the Metre Convention to the vital role of accurate measurements in trade and sustainability, and onward to the future challenges in metrology, including its essential role in helping us achieve our global goals. It is no coincidence that this meeting is hosted by and is held in partnership with UNESCO, which stands as a pillar of global cooperation and shared values in science and education. Recognizing the significance of metrology for the world, the 42nd session of the UNESCO General Conference in November 2023 proclaimed 20th of May of every year as World Metrology Day. In 2024, this day was observed for the first time in this building and around the world as a UNESCO World Day. We have the Republic of Kazakhstan as a member state of both UNESCO and BIPM and also OIML. With strong support from these agencies, was proud to submit the proposal to proclaim the World Metrology Day to UNESCO. We have been asked often, why did Kazakhstan take the lead in this initiative? Why us? The answer lies in our journey. Since gaining independence 34 years ago, Kazakhstan's economy and the society have undergone deep transformations. One of the key drivers that brought our country onto the global economic stage was the alignment of our national metrology system with the international framework led by the BIPM and OIML. The State Program for Industrial and Innovative Development of Kazakhstan supported the reshaping of a national metrology system that is now comparable and recognized globally. Today, Kazakhstan actively participates in the activities of both of these bodies. We are proud to say that our national metrology system contributes to the economic performance of our nation and improves the quality of life of our citizens, just like the metrology does in your countries. We have followed this path to finally understand how important metrology is for our economy and for our people. We also know that there are states in our region, in our part of the world, currently in period of transition. They too need to develop their national metrology systems along with us and integrate them into the global system. And I'm certain that countries in other regions share similar experiences and aspirations. Ladies and gentlemen, the 20th of May, 1875 was a symbolic day for the world. That day, nations came together to sign the Metre Convention, formally launching international cooperation in measurement science. Over the past 150 years, the mission of the convention to assure the international unification and perfection of the metric system, that was a quote, continues to be met and has grown even stronger thanks to you, through global cooperation and our shared commitment to progress. Indeed, as we celebrate the 150th anniversary of the Metre Convention today, we do more than honor a historic treaty. We reaffirm our shared commitment to progress through cooperation in metrology. Let us continue building a world where measurements are not only accurate but meaningful, not only scientific but human. Let us ensure that metrology serves all societies, supports all economies, and empowers all people. Because in the words that now echo across generations, measurements for all time, for all people. I thank you.
Thank you so much, Ambassador. And now it is my honor to hand you over to Monsieur Jean Lamy from the French Foreign Ministry. He's the acting deputy to the head of the Subdirectorate for Diplomatic and Consular Privileges and Immunities. Monsieur Lamy, it's a pleasure. Merci.
Monsieur le directeur des politiques.
Mr. Chao Feng-Hu, Director, Dr. William D. Phillips, who will be giving the keynote address, Excellency, Permanent Delegate of the Republic of Kazakhstan to UNESCO. As we just heard, Kazakhstan took the initiative so that this day, 20 May, is celebrated every year as the World Metrology Day. Mr. Director of the International Bureau of Weights and Measures, ladies and gentlemen, I'd like to greet all the directors and heads of organizations. I'd like to greet delegates and ambassadors, dear guests. It's a pleasure and a great honor for me to take the floor as the representative of the French Ministry for Europe and Foreign Affairs as we celebrate today at UNESCO the 2025 World Metrology Day. We are celebrating the 150th anniversary of the Metre Convention and the establishment of the BIPM. As you know, 150 years ago in Paris on May 20th, 1875, the BIPM was created after years of work by a diplomatic, scientific, and international commission, and after an international scientific conference was organized by the Minister of the Foreign Affairs at the time. One first accomplishment was to gather France and Germany after the Franco-Prussian War of 1810. Exactly 150 years ago, plenipotentiary representatives met a few meters from here in the premises of the Ministry of Foreign Affairs in Paris to sign the base of what led to one of the oldest intergovernmental organizations based in France. As Joachim Dubélé described France, France was the mother of science and arts, among others, and France was happy to welcome this atypical modern scientific gathering. This contributed to creating the metric system and then the SI. and made these systems a system of measurements for all peoples and all countries. France is proud to welcome as well the headquarters for UNESCO. In 150 years, the International Bureau of Weights and Measures has achieved many things. Thanks to its status and its neutrality, the BIPM is the embodiment of multilateralism's achievements. More than once, it has demonstrated its usefulness as it was recalled by Germany and by Angela Merkel during the Davos Forum a few years ago. The unification of measurements was a very important issue at the end of the 18th century when the French revolutionaries established the metric system. Now we know how essential these unified measurements are for our globalized world, for science, for industry, for trade, for the environment, for health, and also to be able to meet the challenges ahead. The Bureau is made up of 64 member states and 34 associates, many different nationalities represented at headquarters at the Pavillon d'Auteuil in Sèvres, where we met last night. Beyond that, the BIPM is an influential international organization, and it has global clout. It's a unique organization. It promotes and drives comparability and traceability at a global level for measurements. Firstly, in the service of scientific innovation, but also for trade. And thirdly, for the improvement of life quality and the protection of the environment. It is the reference organization for the SI. France is also very proud to house in its territory an organization that gathers so many member states, including during conflict. The longevity of the International Bureau of Weights and Measures after 150 years since its creation can be understood because of its universal mission and because it was able to incorporate the innovation of science, of society, and of international relations. The Bureau was able to adapt to world dynamics. Although it is 150 years old, the International Bureau of Weights and Measures is as necessary as ever, and we can see it through its new initiatives supporting climate and digital transformation for our societies. We would like to congratulate this organization and wish the best 150 years to come. I have no doubt that our discussions here today will be extremely exhilarating and important. I thank you for your attention.
Merci beaucoup, Monsieur.
Thank you very much. Thank you, Mr. Lamy.
It is with great pleasure that I invite to take the stage Dr. Wynand Lowe, the President of the International Committee for Weights and Measures for South Africa, who will be delivering our opening address. Dr. Lowe, please.
Excellence, Mr. Hu, Ambassador Abrakmanov, and Monsieur Jean Lamy. Ladies and gentlemen, bonjour, good morning, and because it's Africa Week, Sani Bonani, Lumelang, Goeiemorgen. It is an immense privilege to be here with all of you today and everyone online to celebrate the signing of the Metre Convention 150 years ago here in Paris, at the Ministry of Foreign Affairs. On behalf of the BIPM, I would like to express our sincere thanks to His Excellency Dr. Abdrakhmanov for proposing that World Metrology Day be recognized by UNESCO. I would also like to thank Mrs. Britou and her team here at UNESCO. The BIPM has had a formal memorandum of understanding with UNESCO for over 70 years, making you one of our longest collaborators. The Metre Convention was signed in 150 years ago, as you have already heard today, that established the International Bureau of Weights and Measures with the permanent headquarters here in Sèvres, Paris, and an international committee for weights and measures that first focused on the preparations for the construction of the prototypes of the meter and the kilogram. In 1899, the first General Conference on Weights and Measures, the plenary body of the organization, approved the two prototypes that would be kept at the BIPM headquarters as the international prototypes of the meter and the kilogram. From this moment, the International Bureau became the international center for the propagation of the Metre Convention. The metric system soon became the system of choice for scientific development and trade around the globe. By 1960, it had expanded to 6 base units, and with its derived units was named the International System of Units, with abbreviation SI. In 1971, the 7th base unit for amount of substance was added to give us the SI with its 7 base units and its derived units that we have today. From its beginning with 17 signatories, the BIPM currently has 64 states party to the Metre Convention and 30 associates of our General Conference, CGPM, covering 98% of the world GDP. In addition, at least another 90 member states of UNESCO also apply the SI locally and for trade, covering all recognized states and economies. A particular highlight was when the member states of UNESCO in 2023 adopted 20 May as World Metrology Day, showing the global support for the Metre Convention. With the advent of the quantum era, and especially the fourth industrial revolution, the SI further developed scientifically, and in 2018, the 26th CGPM adopted the revised SI, where the 7 base units were redefined in terms of 7 constants that were adopted as the defining constants. The base units could now be realized independently anywhere in the known universe, and the accuracy of the realizations is only limited by our level of scientific development. In the words expressed at the adoption of the revised SI, the SI has become truly democratized. It is a particular pleasure to be here at UNESCO this week because it is Africa Week as well. You will see in our program today that we have Dr. Henry Rodish, the chair of our regional organization in Africa, AfriMets, and we can all look forward to hearing Dr. Rodish's insights into the rapid progress being made to develop a quality infrastructure in Africa. BIPM has achieved a huge amount over 150 years. We will hear something about this today and in a conference in Versailles the next 2 days. I finish by saying on behalf of the CIPM, the International Committee, how much we thank those that have contributed to 150 years of success in providing measurement for all times and for all people. And I specifically want to thank all the delegates here from the member states and the associates today that funds the activities of our organization. Without your financial contribution and your scientific contribution, the organization could not exist. And I sincerely hope that my successor in 50 years from now would be able to stand here and thank you for our organization. Thank you.
Thank you so much, Mr. Lowe. And now it's for Dr. Bob Joseph Matthew, President of the International Committee for Legal Metrology from Switzerland, to take the stage. Mr. Matthew, over to you.
Excellence, Monsieur Wu, Son Excellence.
Excellency, Mr. Xiaofeng Hu, Excellency, Mr. Asker Abdrakhmanov, Excellencies, dear colleagues, ladies and gentlemen. It's an honor and a privilege for me to be here today to celebrate this momentous day. We are celebrating 150 years since the Metre Convention was signed. I would like to seize this opportunity to thank UNESCO for this warm welcome. We appreciate it. And we'd like to thank UNESCO for the support in preparing this very important moment in the metrology community's life. The General Conference of UNESCO in 2023 adopted 20 May as World Metrology Day. This was an initiative led by the Republic of Kazakhstan. In this context, I'd like to thank His Excellency Mr. Abdrakhmanov for this initiative. We celebrate this day for years now, organized by the BIPM and the CIML. The celebration of this day raises awareness on the importance of metrology for our societies. It also shows that metrology is necessary to support well-being.
Indeed, a central role in topics which are directly related to the daily life of us, the citizens of the world. However, metrology remains often unseen and beyond our awareness. So many of the transactions we carry out in our daily lives are underpinned and reliant on metrology, from using fuel pumps to the scales in our supermarkets and the electricity meters at our homes. Metrology does indeed build trust by ensuring accuracy, providing traceability, enabling comparability, and very importantly, supporting also regulation. Metrology is, in that sense, an essential pillar of the quality infrastructure, together with standardization, accreditation, conformity assessment, and market surveillance. It is, in my view, undisputed that measurements in science and technology are a technical accelerator and a bridge to innovation. In addition to the important role metrology plays in our daily lives, it will continue to play a pivotal role in shaping the future and thus evolve to meet future challenges in various areas such as quantum metrology, as well as the digitalization of metrology through use of AI, integration of IoT in order to create smart measurement systems. It is also worth mentioning that metrological capabilities will further advance, enable, and facilitate the development in healthcare and life science. The original aim of the Metre Convention, the worldwide uniformity of measurement, remains as important today as it was in 1875. It will also continue in the future to provide the basis for coherent measurement systems that underpin scientific discovery and innovation, industrial manufacturing and international trade, and the protection of consumers as well. It is also a key enabler to achieving the UN's Sustainable Development Goals. La célébration de la Journée mondiale.
The celebration of World Metrology Day also reminds us that collaboration between institutions, between players of the industry, between the public at large is fundamental so that we can find solutions for the most urgent problems in the world. Our community can contribute to finding these solutions, and I'm convinced that The last 150 years are but a beginning. Let us work together and let us continue our cooperation with this vision, with integrity, and with passion. Ladies and gentlemen, I wish you a very successful deliberations, and I wish you a beautiful celebration of this day. Thank you for your attention.
Thank you so much, Dr. Matthew. And now, for a pretty big deal in a room of pretty big deals, we really have to pull out all the stops today because our keynote speaker knows a bit about celebrating metrological milestones. He was there for the 100th anniversary of the Metre Convention, and there is also the small matter of his Nobel Prize for Physics. Now, that was awarded to Professor William Daniel Phillips in 1997 for his groundbreaking work on laser cooling and trapping of atoms that had a huge impact on precision measurement and atomic clocks. So he'll be sharing with us the secret of SIOPS. SIOPS? No? Okay, fine. I thought I'd give it a go. But they're everywhere, shaping everything. So, Professor Phillips, I am not alone in saying that it is a real honor to have you with us. Over to you.
Well, thank you very much for that kind introduction. Can we put my laptop up on the screen? Thank you. A new measure, the revolutionary quantum reform of the modern metric system. It is World Metrology Day. What a wonderful time to celebrate 150 years of the BIPM, 150 years of international metrology. And earlier this year, in this very place, the UNESCO inaugurated the International Year of Quantum Science and Technology, and I want to emphasize the close connection between these two celebrations because more and more the international system of units is becoming quantum-based, and I'm going to tell you a little bit about that story. But first I want to emphasize how pleased and how honored I am to be representing the National Institute of Standards and Technology and the United States of America here at the 150th anniversary of the Convention du Metre and the creation of the BIPM. The United States was one of those 17 original signers of the Convention du Metre. And it's true that the United States sometimes takes a little bit of justified criticism in not embracing fully the metric system, at least in its daily life. But we have been from the very beginning an extremely strong supporter of international metrology and of the mission of the BIPM, and we have been metric since even before the Convention du Metre, at least legally. As you've heard, I was here in Paris for the 100th anniversary of the Convention du Metre and for the 125th. At the time of the 100th anniversary, I was a graduate student and attending one of my first international meetings, in this case about metrology. Atomic Masses and Fundamental Constants 5 was the name of the conference. And at that time, France issued a special commemorative stamp for the 100th anniversary. And as you'll see on the stamp, at the center is the meter. At the top of the wheel and in the center of the nucleus of this stylized atom, and also the wavelength shown there at the bottom of the stamp, all affirm the importance of the Convention du Metre as the center of metrology. The conference was introduced, or at least he wasn't able to be there, but the famous French physicist Alfred Kastler reminded us at the beginning of the conference of the ancient story of the Tower of Babel as told in the Bible, and suggested that in addition to the proliferation of language, that this event had resulted in a proliferation of standards of measurement. And he said, while the proliferation of languages was still something that we labored under, that when it comes to units of measurement, the curse has been charmed away, and a universal system has now been established. And of course, he was talking about the Système International d'Unité, the international system of units. Well, that was the 100th anniversary. At the 125th anniversary, one of the highlights of the visit was a chance to actually see in person the international prototype kilogram. And here I am with Rich Davis, one of the heroes of international mass metrology, standing in front of the triple glass globes that contain the international prototype kilogram. That was a tremendous thrill for me, to see the actual kilogram. Now, much of the story of international metrology has been in making measurement more accessible, more useful, and more accurate. And this recent quantum reform of the SI is only the latest example of this. And you've been hearing about it, and the International System of Units with its 7 base units now, as you've heard, is based upon defining constants of nature. Now, in order to understand how this comes about, I'm going to tell the story of the meter itself, of the metrology of length, a short version of that history. But the story is one that is truly instructive of the way in which the international system of units has evolved today. The early approach to length was to use the human body. A fathom was a person's wingspan. A cubit was the distance between the elbow and the fingertips. A foot was a foot. And this was really convenient because you always had your standards of measurement with you. On the other hand, it was not particularly consistent. If you were buying fabric from a short fabric merchant, you might not get what you expected. So even ancient people had an approach to fix this problem, and that was to decide on a single person and use the body of that single person. And in ancient Egypt, that was the pharaoh. But they were more clever than that, because the pharaoh was not always around, especially when you were building the pyramids. And so they produced a stone replica of the pharaoh's forearm, and this became the artifact standard of measurement. And as you've heard, the production of the pyramids was rather remarkably accurate. In fact, the baselines are square to just a few hundredths of a percent, and the angles are correct to a few seconds of arc. It's really remarkable achievement, achieved by professional metrology. And these people were really serious about their metrology, because the engineers in the field who were building the pyramids were using secondary standards made out of wood that had to be calibrated every month against the stone standards on pain of death if you did not recalibrate. So these people really were serious about metrology. And the results, as you can see, were quite remarkable. In a more modern era, similar artifacts were common throughout Europe, for example, often cemented into the walls of the town square. And here we see a tourist, in fact, the spouse of a metrologist, who's comparing her fathom against the official fathom of Regensburg. And it looks like this would probably be a very good place to buy things by length. But if you were to go into the surrounding towns of the area, you would find a completely different set of measurement standards. And this was exactly the problem that the French revolutionaries saw as being ripe for solution using the philosophy, the principles of the revolution. They decided to make length democratized and defined a new standard of length called the meter, which was 1/10,000,000th of the distance, the meridian, between the North Pole and the equator along a meridian, just to make sure that everything was completely universal, the meridian that goes through Paris. What did they do? They, well, first of all, the philosophy here, as you've heard before, and it's commemorated in these memorial coins, was to produce a system of units that was good à tous les temps, à tous les peuples, for all time, for all people. And in this medal, you see a mythological creature who is measuring the Earth. And that's exactly what they did. They sent out teams of surveyors, astronomers, to measure the distance in the old units between Barcelona and Dunkirk, and then extrapolated to the rest of the meridian. And with these new units, they knew the length of this new measure, the meter, that was to be the measure of all things. But you know what they did? They did the same thing that the ancient Egyptians did. They created an artifact. This platinum rod became the meter of the archives, based upon that measurement of the Earth, but a more practical way of using the meter. And it was deposited in the archives of France in 1799, at the end of the 18th century, and it became the standard of length for all of France. In that wonderful year of 1875, the Convention du Metre mandated the creation of a new standard. The meter, the length of that meter of the archives, was enshrined as the distance between two scratches on this platinum iridium rod, and it became the meter for the entire world. But this is the end of the 19th century now, and physicists had learned that light was a wave, and they had learned how to make instruments like this interferometer, this Michelson interferometer, that allowed the precise measurement of length or displacement in terms of the wavelength of light. This wonderful instrument, when this mirror is moved by a quarter of a wavelength of light, approximately 2/10 of 1/1,000,000th of a meter, changes the interference pattern produced from having a dark spot at the center to having a bright spot at the center. 2/10 of a millionth of a meter. The scratches on the international prototype meter have a width of approximately 20 millionths of a meter. So now you have the uncomfortable situation where you have a technology, optical interferometry, that can measure length better than the definition of length itself. And so people began to measure length using light in a sort of de facto way, where the wavelength of light had become the de facto but not the legal standard of measurement. It took some decades, because of the conservative nature of metrology, which extends till today, to redefine the meter in terms of the wavelength of light. To embrace this new technology, they defined in 1960 the wavelength of light from a krypton lamp. The lamp is shown here. When you excite the lamp electrically, it gives off a beautiful orange color light, and the wavelength of that orange light was defined in 1960. The year, by the way, in which the laser was invented. Well, that enshrinement of krypton was commemorated in this stamp. You see krypton here. And this was the realization of a dream of scientists from the 19th century. We've heard earlier from, where is Miss Kelvin? So Lord Kelvin was, along with James Maxwell, was one of the people who advocated the use of natural standards as standards of measurement. And Maxwell said, thinking already in the 19th century that light would be a good standard, that such a standard would be independent of any changes in the dimension of the Earth, and then jokingly said, and should be adopted by those who expect their writings to be more permanent than that body. Well, this krypton lamp was soon superseded by the fact that lasers were making light that was more pure than the light that came out of the krypton lamp. And lasers like this, a helium neon laser stabilized to a particular transition in molecular iodine, became the unofficial standard of length, because again we had a situation where the technology had outrun the definition. And that uncomfortable situation again needed to be corrected. And people were using this de facto standard of length again, and obviously we needed to redefine the meter. And the obvious way to redefine the meter would have been to define the wavelength of the light coming out of an iodine-stabilized helium neon laser. But fortunately, the world metrology community did not do the obvious thing. Instead, they did something beautiful and brilliant. They defined the speed of light. And this is the wonderful story that has become the uniform story for the SI. So what does it mean to define the speed of light? The new definition was that the meter is the length of a path traveled by light in vacuum during a time interval of this fraction. And the denominator of this fraction is then, by definition, the speed of light in meters per second. Now here's the beauty. If we define the speed of light and we measure the frequency of the light, and by 1983 people had learned how to measure the frequency of light, you immediately know what the wavelength is. So it doesn't matter what the light is. If you measure its frequency and if you define the speed of light, you have a ruler that is calibrated in SI units. Now the beauty of this is that if someone makes a better laser, and they did, if someone develops a new way and better way of measuring the frequency of light, and they did, it's immediately incorporated into this new definition. And the definition gets better as the technology gets better, but the definition itself doesn't need to be changed. Well, here are two of the heroes. They got the Nobel Prize in 2005 for making better lasers, for developing better techniques for measuring the frequency of those lasers. And we have this beautiful culmination of the story of length, that we started from length as an artifact, turned into length being defined by a natural constant of nature, that is the wavelength of krypton. And finally, the real beauty is in defining length by defining a fundamental constant of nature, the speed of light. And we should never need to change again. Now, the rest of the story. In May 20th, this very day in 2019, the international metrology community brought the beauty of this way of defining a constant, by defining a fundamental constant of nature, brought this beauty to the kilogram, and for that matter to the ampere, the Kelvin, and the mole. What a wonderful day. Well, why was this done? Why did it have to be done, particularly to the kilogram? The kilogram is the star of this story. Why and how? Well, why goes back to the revolutionaries of the French Revolution. In the spirit of making the meter the measure of all things, they wanted to make a kilogram, the new unit of mass, based on the meter. And so they defined this new unit of mass, the kilogram, as being the mass of the amount of water that you could put into a cube that was 1/10 of a meter on a side, what we call a liter. So the mass of a liter of water is defined to be a kilogram. Well, it turned out that it wasn't that easy to get exactly 1 liter of water, and there were issues having to do with the density of water depending on temperature. And so, guess what? They made an artifact. They manufactured a platinum cylinder that's called the kilogram of the archives, as closely as possible to a liter, the mass of a liter of water, and deposited it in the archives of France in 1799. Not too long ago, I made a visit to the archives of France with Terry Quinn, former director of the BIPM, and there I am holding the kilogram of the archives. Not just looking at it through the doors in the BIPM, but, I mean, of course, it's not it's not the kilogram anymore, but for years it was the unit of mass for the country of France. And there I am holding this little bit of platinum, which, of course, in 1875 was replaced with the kilogram for the world, the International Prototype Kilogram, which you see under these glass covers. And, of course, this is what we're celebrating today, the Convention de Metre, which, along with a new definition of the meter, a new prototype meter, gave us a new prototype kilogram. So this is, until just a few years ago, the definition of the kilogram for the world. It's the unit of mass equal to the mass of the international prototype of the kilogram. Now, my friends, think about this. It's the 21st century. We have a unit of mass that is an artifact, a piece of actual metal that was made in the 19th century, but it was based upon the object that you've seen that was made in the 18th century. In fact, they made a lot of copies of the kilogram, as identical as they could, and the one that was closest in mass to the kilogram of the archives became the International Prototype Kilogram. But to imagine that we are in the 21st century using this artifact whose history goes back to the 18th century is truly scandalous. If somebody left a fingerprint on the international prototype of the kilogram, all of you would lose weight, and not in a way that would be helpful at all. So this is intolerable. We had to change this scandalous situation, and of course, we don't leave fingerprints on the international prototype of the kilogram, but that kilogram is changing nevertheless. Here is a plot of the relative mass of a number of the identical copies that were made at the same time over a period of many decades. And you'll see that almost all of these copies are drifting, becoming heavier relative to the international prototype kilogram. Now, you might think, it doesn't take too much imagination to think that maybe the international prototype kilogram is getting lighter rather than all the other ones getting heavier. Obviously, some mix of some things getting heavier and some things getting lighter. But of course, the international prototype of the kilogram cannot get lighter. It would be illegal for the international prototype kilogram to change mass because it is by definition and by law a kilogram. Well, that's not a very good situation, and that has to be changed. And so we wanted to change it in a way that reflected the same beauty that was used in the definition of the meter. So for defining the meter, we defined the speed of light. what constant shall we use for the kilogram? Well, to show that, let me remind you of what is surely the most famous equation of all time. E equals mc squared. Einstein's famous relation tells us that the energy of an object at rest is equal to the rest mass of that object times the square of the speed of light. Now, there's another equation, not quite as famous, but well known to many people, that the energy of a photon is equal to Planck's constant times the frequency of the light that represents that photon. So we just take those two equations and set them equal to each other and solve for the mass, and we find that the mass is equal to Planck's constant times the frequency divided by the square of the speed of light. Now, what does this equation mean? Imagine you had an object, let's say an atomic nucleus, that was radioactive, and it emitted a gamma ray, a photon of high-frequency light, and you could measure the frequency of that gamma ray. Then this equation tells you the change in the mass of that nucleus because it emitted a photon. Essentially, the experiment would be that of weighing a photon. Well, we don't weigh photons. Actually, we do. It's just that we can't do it well enough to use it as a mass standard. This is simply to indicate to you how defining Planck's constant can give us a standard of mass. Instead, we do it in a different way, a way that's very near and dear to my heart because, as you've heard, I've been involved in laser cooling, and you have to start with a sample of laser-cooled atoms. So imagine that you've got an atom at rest in the ground state, and you shine in a laser that can excite the atom, and you know what the frequency of the light is, so that means you know the energy of the photons, h times the frequency, and you know the momentum of the photons, which is h Planck's constant divided by the wavelength. And you know the wavelength because you know the speed of light. Everything is known very well. The light is absorbed by the atom. The atom goes into the excited state, absorbing the energy of the photon, but it also absorbs the momentum of the photon. So now the atom is moving with a velocity corresponding to the conservation of momentum. So that velocity is Planck's constant divided by the mass and the wavelength. Solving for the mass, we have that the mass of the atom is equal to Planck's constant divided by the velocity and the wavelength. Now, it turns out that we have techniques for measuring the velocity, and the cartoon version that I've shown you here is an oversimplification of how we do it, but I don't have time to tell you how it's really done. Ask me afterwards, and I'll be happy to explain it to you. But the point is, we can measure all these things, and that means we know what the mass of the atom is. It's usually rubidium. We know what the mass of the atom is in kilograms. Now, we're used to knowing about what masses of atoms are in atomic mass units, but now we know what the mass of the atom is in kilograms. So all we need to do is multiply that up, getting lots and lots of atoms together whose mass we know, and now we've got a kilogram. Well, how that's done is a wonderful story all of its own. At PTB, they make near-perfect spheres of single crystal silicon that's also isotopically pure. These are the most spherical objects ever made anywhere on Earth. And you use X-ray interferometry to give you the spacing between the atoms. You use optical methods to measure the dimensions of this sphere. And if you know what the spacing of the atoms in the perfect crystal is, and you know what the size of the sphere is, you know how many silicon atoms are in this sphere, and you know the mass of the silicon atom in kilograms because you've compared it to rubidium and you measured the mass of the rubidium. So now you know the mass of this object, and you can make it be a kilogram. But it's not an artifact. Anybody can make one of these things, as we've heard, if they have the right techniques and the laboratory skills. This is one of the ways that today we realize the new definition of the kilogram. But It's not the only way. And I wish I had time to tell you about this method. Brian Kibble invented a new kind of electromechanical device, which we now call a Kibble balance, that enables the realization of this definition, again, using a defined value of Planck's constant. You can realize the kilogram. And here's a picture at my institution, at NIST, of one of these Kibble balances that is used to realize the kilogram to about a part in 10 to the 8th, which is better than the amount by which these various kilograms are drifting relative to each other. So now we can start to study what's causing that drift, and that's being done today, and we can be guaranteed that we have a definition of the kilogram that isn't going to drift. Well, all over the world, there are laboratories using Kibble balances, using silicon spheres, including right here in France at the BIPM. In fact, the opening movie showed a little clip of the Kibble balance at the BIPM. So when all of these experiments all over the world agreed on their results, then the international community agreed to change the definition of the kilogram. And it was in Versailles in 2018 that the General Conference of Weights and Measures made that agreement. 60 countries of the world agreed unanimously to do this, and they showed this movie.
More than 140 years.
Groundbreaking science.
And the agreement from the world's scientific community.
At times, it seemed
impossible.
Accurate.
Precise measurements.
Anytime.
Anywhere. But
we did it. Ce l'abbiamo fatta.
Wir haben es geschafft.
Lo logramos.
我们做到了. Biz buna nail olduk.
Proud om daar.
we wonnen zasadıq. Het is ons gelukt.
We сделали это.
انتصرنا.
We gjorde det.
Amerika.
Mi smo to učinili.
Dokázali jsme to.
أنجزناها.
سويناها.
Congratulations.
축하합니다.
Felicitaciones.
Mazal tov. Congratulazioni.
Shatter lavorisha.
Selamat sukses.
Parabéns.
Ongera. Omedeto.
감사합니다.
Onneksi olkoon.
Mabruk. Kapai.
Aiko.
Félicitations. Congratulations.
Yes. I hope that many of you recognized your own languages in that video. Some of you may recognize yourself in those videos. And every time I see that, even today, I get emotional, because 60 countries of the world at that time, 60 signatories of the Convention du Metre, agreed unanimously to do something for the good of the entire world. And it was not easy. There were lots of disagreements about how this was to be done, but they did it. They did it unanimously. They did it peacefully. What a wonderful inspiration for how we ought to take care of things in an international way. Well, it wasn't just mass. The ampere was redefined in a similar and very quantum way. It used to be that the ampere was defined in terms of the forces between current-carrying wires. And now we've defined the charge of the electron. And since current is simply charge per unit time, it means that the ampere is a certain number of electrons. Now, we don't do it that way, or at least not yet. We're working on it. But we do it a different way, because with both E and H defined, the Josephson constant, 2E over H in volts per hertz, and H over E squared in ohms are now exact, and we can use the Josephson and the quantum Hall effects to measure all of our electrical quantities. But there's more, 2 more units. The mole used to be the amount of substance that corresponded to the number of entities that is equal to the number of carbon-12 atoms in 12 grams of carbon-12. You all learned that in high school chemistry. But now, it's just a number. We've defined Avogadro's number, and what a wonderful way of bringing the microscopic into this understanding. And then, of course, the Kelvin. Used to be 1/273.16 of the triple point of water. Now we have it by defining Boltzmann's constant, which is beautiful because it tells us what the energy of one of the atomic constituents of the material whose temperature we're trying to measure. So this is very much at the atomic and at the quantum scale, very much a quantum way of thinking about the international system of units. Well, the French Revolution brought us the metric system, with meters as the measure of all things, kilograms as a measure of mass based on the meter. The Convention de Metre brought the metric system to the world. And on the 20th of May, this very day in 2019, the metric system was reformed in this quantum way so that we are basing our units on constants of nature. And today we're celebrating the blessings of this universal system of measurement that stretches from the French Revolution to the quantum revolution of today, and we're looking forward to more progress in the future. And so this stunning painting of liberty leading the people means in this context that we are free of artifacts of standards of measurement, and anybody can realize the standards of measurement. All the base units of the international system of units are defined by fixing the values of constants of nature. And we're bringing to the SI the dream of those French revolutionaries to have something good à tous les temps, à tous les peuples, for all time, for all people, except, it seems, for time itself. Because time is defined by reference to a specific atom, cesium, rather than to a fundamental constant. The hyperfine frequency of cesium is defined to be this number, and that's what we use to define what we mean by a second. Now, the problem is that this is a microwave transition, and using that microwave transition, we can realize the definition of the second in the SI to within a few parts in 10 to the 16. By far, the best realization of any of the units of the SI, a few parts in 10 to the 16. But we now have other atoms with optical transitions that can be realized to better than a part in 10 to the 18. So this shows the evolution with time, and I'm running out of time, by the way, of the microwave clocks and the optical clocks. And you see a little bit after the year 2000, the optical clocks took over, and they're just getting better and better all the time. And we are now at a kind of a crossroads where we have been before, where we have to decide how to redefine a unit of the SI, because we now have a technology that is better than the very definition of that unit itself. And we have a wonderful array of possible atoms and possible transitions that could allow this redefinition. Some of them are bosons, some of them are fermions, some of them are ions, some of them are neutral atoms. What are we going to do? Well, later this week, we will have a discussion, and I hope you will all come and be part of that, in which we talk about the possibilities for the redefinition of the second. What is that definition going to be? Well, only time will tell, but those of you who are in charge of national measurement, national metrology institutes, we need your data from your optical frequency standards to be able to make the best decision for this next step in the development of the SI. It's been a tremendous trip. I'm running out of time, and I thank you very much for your attention. Thank you. Okay, I think
Thank you. Thank you so much, Professor Phillips. That was super fascinating, particularly as a layman. And what's super interesting is in a lot of the work and conversations that's gone into, being here today, I've learned so much stuff that gives you that feeling that, the first time that you put on glasses and it completely shifts your understanding as to what sight is supposed to be and supposed to deliver for you. Now, when it comes to things like the second, the meter, and the mole, I never really thought about why, how, who. They were just tools. They're always there. They should always be there. They make sense. Why? How could we be what we are without them? And you don't realize that there is actually a story behind them. And thank you so much for Professor Phillips for talking us through some of the drama, because I was so wrong. Lasers, pharaohs, revolutions, big feet, life and death software updates, meeting a hero that did not disappoint. Metrology is not just a springboard for collaboration that mankind could not do without. It's also a deeply gripping soap opera that doesn't seem to be at risk of being cancelled, and for that I am deeply grateful. So thank you for everyone who's got us this far this morning. I think that set us up nicely for the first discussion of the day, which will be navigating the future of metrology, addressing scientific and technical multilateralism and challenges. For that, I will be, okay, clearly you can see that they may, gentlemen, are you playing? I'm getting eye contact. Gentlemen, are you expecting to play? And we have a beautiful musical interlude from the Malik Dior Band before we have our first panel of the day. Gentlemen. And I think that has put us in a lovely headspace for that promised discussion that's going to be led by Dr. Magdalene Chambon, in which we will be looking at navigating the future of metrology, addressing scientific and technical multilateralism challenges. Magdalene, over to you.
Ladies and gentlemen, dear colleagues, distinguished guests, it's really an honor to be there today. But before to start this session, first I am sure that we will all agree, I would like to really thank Dr. Bill Phillips, because I think that he's really the best ambassador of the Metre Convention. Thanks really, Dr. Phillips, for that. Then, before to ask the panelists to come on the scene, we will have a short movie, and then I will introduce the session. Please.
Metrology powers global policies by turning precision into progress, ensuring every decision based on accurate, consistent, and trusted measurement.
Reliable measurements are at the heart of effective policy. They make decisions trustworthy. As the world changes, metrology must also evolve. With technology like AI, big data, and machine learning, we are pushing the boundaries of precision in areas like healthcare, energy, climate, and digital communications, fields that truly impact our lives.
As cutting-edge industrial technologies continue to develop, the need for measurement with increasingly higher accuracy is growing. Quantum metrology will play a vital role in supporting global policy goals, such as improving human health and well-being. In particular, quantum computing will enable molecular analysis to address issues related to genes, disease, and aging, thereby advancing biotechnology and contributing to sustainable global development.
Trabajamos por posicionar las mediciones con base científica en el desarrollo, acercándonos a los tomadores de decisiones y articulándolos con marcos normativos y de cooperación internacional. Esto permite construir redes de conocimiento técnico que impulsan la competitividad, la sostenibilidad y la innovación de un país como Colombia.
By collaborating with partners like BIPM, we are taking metrology into the digital age, actively driving better and more informed global policies.
I am convinced that metrology will continue to drive progress in science, in industry, and in society as a whole the next 150 years.
So now we will start this session on the multilateral cooperation. And just I would like to introduce this subject, and for that I will first ask the panelists to join me on this table. So I will first call Mr. Xiao Fengyu, Director, Division of Science Policy and Basic Science, Natural Science Sector at UNESCO. Mr. Yu, are you there? Yes, please. Then the second panelist, Professor Alessandro De Angelis, Scientific Attaché at the Permanent Delegation of Italy to the International Organization to Paris. Thank you. I will continue with Professor Mustafa Setinas, presently Director of the TÜBİTAK UME, the National Metrology Institute in Turkey. Sharon Mae Smith-Walker, Chief Executive Officer of CARICOM, the Regional Organization for Standard and Quality in Jamaica. And last but not least, Dr. Victoria Coleman, National Metrology Institute of Australia. So thanks to all these panelists to be with us this morning. So just to introduce, for the beginning of this morning, of this day, you understood that, and you know that BIPM was founded in 1875, that it's the oldest international organization based in Sèvres, and the second oldest in the world after the ITU, the International Telecommunication Union. This is really also an important step, but we had also a second step with the creation of OIML, the Organisation Internationale de Métrologie Légale, was been founded in 1955, so it's also an important day for them, I guess. So whilst the BIPM started just with 70 members in 1875, we are now more than 100 member states or associates, and this is really a fantastic adventure. The growth of BIPM has been continuous over these 150 years, and the participation also has grown, and the work, because when you see all the work done from 1875 up to now, it has been a very long step. If you look in particular at the CIPM mutual recognition arrangement in 1999, from capacity and measurement capabilities, that was a really enormous step, but also on capacity building, because it was important for BIPM to have all its members participating in this organization. So this is really a big step that has been done by BIPM, and as you know, this session, and thanks to BIPM to have put this session just after the talk of Bill Phillips. This put us comfortable for sure. So this session will be provide the opportunity to the panelists to highlight the benefits for multilateral cooperation on technical and scientific topics such as metrology, and also to look ahead to possible future strategy for international organization. And this has been underlined by our representative of the Ministry of Foreign Affairs, Dr. Lamy. Comme je suis citoyenne française, il ne m'est pas possible de ne pas dire 3 mots en français, étant donné...
As I am a French citizen, I have to say a few words in French because metrology is initially based on the French language. So I would like to thank all panelists for their presence today. And I'm very proud to be able to participate in this World Metrology Day, which really represents a major step forward in the history of metrology.
Start this roundtable on this topic. It's working. Yes, it's working? Yeah. So, I think that we will start. So we will have 5 panelists, some questions to these panelists. I will first start by Mr. Wu. So, Xiaofeng, if you want to start. So, you are the director of the Division of Science Policy and Basic Science at the United Nations Education, Scientific and Cultural Organization, UNESCO. Can you give us some short statement on what you are, who you are?
Yeah, I'm the Xiaofeng Hu, and that's who I am. And so I'm the director of the science policy and the basic science. Basically, you see, we are promoting science policy and like the open science, like the women in science and the science popularization, science communication, science literacy. And we also, you see, try to work with global partner and to update, you see, the trends, the frontier of the science technology development and the building the capacity of the STI science technology innovation system in the global south. That's basically what we are doing. Thank you.
Thank you very much. So I will start with one first question about diplomacy and scientific diplomacy, and I think that presently it's quite important. We see that. The International Decade of Science for Sustainable Development, led by UNESCO, identifies the importance of scientific diplomacy, local engagement, and cross-sector collaboration. What insight does this provide about the unique role of metrology in your point of view? Yeah.
Thank you. And really, you see the science, international decade of science for the sustainable development is a very big initiative that's proclaimed by the United Nations General Assembly in the 2023 August in New York. So it's really given us a chance and the globally how we can force the international the SDG implementation by using the science and technology. And the UNESCO, as the lead agency for coordinating the implementation, we coordinated all the partners, developed the strategic plan, and we set up of the institutional structure for the implementation. And among you see the international, the science decade, and we identified the very three key pillars and under the science decade. The first one is really science diplomacy, and how you see that globally we can work together and to really advance science through the global incorporation and to really to reach, you see, the SDG target. And the second, you see, like what you said, you see, we really want to engage all in the science development process and also benefit the science. So that's why we say the get local and get, you see, all the unpresented, undeserved, you see, the group to be engaged in this process. And we also like really promote the intersectoral, interdisciplinary cooperation, because what we face today, we need really, you see, the cross-sector collaboration. So in this regard, really, you see, the metrology give us a good opportunity for us, is very, very essential for us. So as we all talked about, I like you see the what you just, the screen in the film, and we know you see the metrology, how important for the policy making, how important and for the, driving the science progress in the next. And also we know you see that really the metrology is really the objective and is neutral and universally you see the comparable. So that's really, you see, the basis for us to build, you see, the trusted framework for the science collaboration, for all the collaboration. That's why we say, you see, the metrology is the fundamental, is the cornerstone for us to move forward under science diplomacy and for the implementation of the international science decade in the next few years. I think I just stop here. Thank you.
Thank you very much, Xiaofang. I think that you underline what is really important, and I think that all my colleagues will agree that metrology is really cross-disciplinary, that we are always comparing ourselves to the others, and that's really important in neutral science to develop new innovation, and that's thanks for that. If I continue with a second question, how can global metrology community engage in the implementation of the science decade for the pursuit of sustainable development goals? So really sustainability for the metrology. Yes?
So basically you want to ask, you see, the metrology and
how do you think that the metrology community can engage the implementation of science?
Yeah, that's okay. That's a really good question, and I think that we discussed, and the metrology is really the basis for the science progress, like the professor just mentioned, and we still also face a lot of challenge. And in this area, as I already mentioned, is for the science policy. For the policy making, the metrology is really provided the trusted framework for all the community to work together, to communicate each other. And like you see for the SDGs, in all the different, you see, SDG areas, we need to have measurement. And for the carbon dioxide emission, so we need to really have the measurement, and we need to really measurement the pollutant if we want to get the collaboration. We need to measure, you see, the renewable energy efficiency in the different area. So we can really, you see, for the carbon credit, you see, exchange, the trading, we also need to have the very reliable measurement. Then you see, we can build, you see, the trusted system, reliable system for us to move forward. Of course, and we understand, you see, like a lot of the speaker already mentioned, the metrology is really behind. It's not visible. It's the enabler, but it's a hidden enabler. So we hope through the science decade, we can also use it to bring more visibility for the metrology, for the young generation. They can learn, they can love, they can get engaged in the metrology. Yeah. And also currently we saw that you see still some countries, they are still in the process right now to adopt, you see, the Metre system, the Metre Convention. So we still have a long way to go, and hopefully through this science decade, and which provide the good platform for us and to build, to enhance metrologic, infrastructure and for the sustainable development. That's a good opportunity. Let's try to work together, working with the different sectors, working with the different international organizations, and within our country with different ministries, and working with the schools even. And so we have very, very good opportunity for us to work together. We can initiate, the proposals, and long-term, short-term, globally, locally. So that's all what we can do. And I just want to highlight maybe one thing, you see, for our science, the decade is really, you see, decentralize the process. And we really depend on all the partners. They can initiate under their mandate by using their resource, but we just provide the platform for us to work together and to show that we are working, we are there, and we can collaborate. So that's, you see, the center of the science decade. It's just the platform. So that's really the good platform, and it's a good opportunity for the metrology and to work together. Thank you.
Thank you, Lord Xiaofeng. So now we will go to another topic, and it will be to highlight the historic role of Metrological Association as a foundation for international cooperation and economical integration. And we are all participating in regional metrology organizations. So I would like Sharon Mae to answer to some questions. So Sharon Mae, what makes technical cooperation in quality infrastructure, especially for metrology, because we have dealing with metrology today, in the Caribbean community, a unique public good that benefits in all participating nations?
Thank you, Magdalene. Excellencies, distinguished ladies and gentlemen in the audience and online, especially those watching from the Caribbean, good day to you all. I am Sharon Mae, Dr. Sharon Mae Smith-Walker, and I'm the CEO of the CARICOM Regional Organization for Standards and Quality, CROSSQ. And on behalf of the 15 member states that I represent today, I'd like to say Happy World Metrology Day and happy 150th anniversary. I had to get that in. Now to your question, what makes technical cooperation in quality infrastructure, especially for metrology in the Caribbean community, a unique public good that benefits all participating nations? I'll answer the question in the context of the very insightful theme, measurements for all times, for all peoples. This theme emphasizes the concept of community, irrespective of geography, irrespective of age or nationality. We work together as one. It reminds me so well of an extant metrological question raised in the Bible in Isaiah 40, verse 12, which says, "Who hath measured the waters in the hollow of his hand, and meted out heaven with a span, and comprehended the dust of the earth in a measure, and weighed the mountains in scales and the hills in a balance?" This inspired question confirms community, inferring that the three branches of metrology connects to the omnipotent designer of the universe who anchors all peoples. And we saw that we had to return to nature to define the meter using light. As a community in the Caribbean, we collaborate through the CARICOM Regional Organization for Standards and Quality to grow our regional quality infrastructure using shared resources supporting standardization, metrology, and accreditation. And this is reinforced using quality promotions across the region. We accord with a wider CARICOM family through the theme, Strength in Unity. And though we are constrained by economic and technical resources, we are resolute in creating a regional quality infrastructure that advances the health and well-being of Caribbean peoples, but more importantly, supports regional and international trade. Our cooperation in metrology is a case in point. Jamaica led the region in becoming the first associate member of the CGPM in 2003. Yes, just the other day. And soon after, the newly formed Caribbean community, representing 11 member states, became a member in 2005 to the CGPM. And these 11 member states include Antigua and Barbuda, Barbados, Belize, Dominica, Grenada, Guyana, St. Kitts and Nevis, St. Lucia, St. Vincent and the Grenadines, Suriname, and Trinidad and Tobago. Together, we have a total of 23 CMCs. Yes, you may think it's very small, but to us, it's a big deal. And those CMCs are concentrated in mass and mass standards. We have a long way to go to catch you up, and we have several comparisons. Our aim through our technical cooperation is to have the other 3 member states become a part of the CARICOM CGPM group and to increase our CMCs and comparisons to support our regional developmental initiatives. Our regional construct is indeed a unique public good because it enables all 15 member states of the CARICOM region to benefit from the metrological capabilities within the region. Individually, our member states are unable to create the kinds of laboratories that may be common in developed countries. And so together we work to support each other. And this is why for us, it is truly a public good.
Thank you very much. So I will go to a second question, if you want, Sharon May.
Sure.
In the context of CARICOM efforts, what is the future outlook for enhancing international cooperation, undergirded by regional engagement? Are there specific challenges or success stories that illustrate the benefit for regional harmonized quality infrastructure? You gave us an example of calibration and measurement capabilities. This is one point. Do you have some other one?
I will share another. The CARICOM member states cooperate regionally to bolster our regional quality infrastructure. And it's important to understand how crucial our metrological capabilities is to our regional quality infrastructure. As a matter of fact, I would consider it the linchpin in our quality infrastructure. Why do I say this? We have national standards bureaus across our member states, but each member state on its own, as I mentioned before, is unable, and perhaps it would be financially and technically impracticable for each member state to build out the pillars of the quality infrastructure. So with respect to metrology, with respect to accreditation, we have to share our resources. We, through the metrological capabilities established in the region, we were able to establish 2 accreditation bodies, one in Jamaica and one in Trinidad and Tobago. And it is a consequence of where we are metrologically now that the accreditation body in Jamaica was able to become a signatory to the ILAC MRA for 5 different scopes. We are thankful that we have an accreditation body that closes the quality infrastructure pillar in the region. Without the support from metrology, we would not have been able to accomplish this. And so we have a crucial path to resilience in our CARICOM nations. We must work together to support each other. And this is crucial for our trade because, as you know, the World Trade Organization, through its technical barrier to trade agreement, requires that we have transparent conformity assessment procedures and systems. And if we do not have a complete quality infrastructure, then certainly we are going to be left behind. Despite our progress, however, we continue to face significant challenges. And especially as we're focusing on metrology, I'm going to focus on some of the constraints that we have with metrology, or metrology legislation. For many of our member states, our laws are outdated and they are not harmonized with international specifications. This is something that we are working on, but there's a lot of work left to be done. We speak of traceability, and I'm so honored to be here at the heart of where it started. We have gaps in our traceability. We want to ensure that when we are moving our sensitive artifacts across the region or in Latin America, to have them calibrated, that we don't lose them, as occurs sometimes, or have them damaged. We have these issues with the logistics within the region. In terms of our capacity to advance metrology for meteorology, which is crucial for us as small island developing states, especially with the issue of climate change, we need more resources. Training and capacity building, we are grateful for the support that we have received from our partners right across the world, but there is so much more need for us to have our technical team members build the kinds of competencies and capabilities that we need to drive metrological revolution in this generation. We continue, even as we have our senior metrologists leave to go to, greener pastures. So we continue to have the brain drain. Even as we build, we lose some of our key people. So there is a critical place where we are today with digital transformation. We are challenged because we need significant resources to keep a pace with technology. And if we are unable to keep a pace with where we are, then we look into the future and see more challenges, because we need the agility. We need to move quickly to ensure that our consumers, the peoples of the Caribbean, or traders and manufacturers are able to perform at the level that is required to meet their developmental agendas. And it is because of this why we must leverage our relationships. We must build relationships. We have to continue to grow our relationships, because it is through the community, through those of you who are stronger, who are able to help us to meet these challenges that we face. I think that is it.
Thank you very much, Sharon Mai. I will continue before giving the floor to Professor Angelis. I will give also some word on the experience of Euramet, because Euramet is a regional metrology organization for Europe, and centrally it's like in Caribbean, but in another way. In Europe, it has been really important, especially after 1989 with the reconstruction of Europe, to have a strong regional metrology organization. This strong scientific and technical cooperation has enabled integration of many countries into the European Union, and this is a continuous process, and it's important also for all of us. This has been also strongly reinforced, and we had the chance and the opportunity to have some European Commission who has funded some research project, to really push all the European countries to strongly and deeply collaborate together. This collaborative project structure has really strengthened relationship between all our metrology laboratories in Europe. This is not only the point research, it's important, but we had also like BIPM initiative. We had some strong initiative on capacity building and knowledge transfer to really push all the country to collaborate together, and Mustafa will give us some statement later on. So I think that's in another way, it's not like Caribbean, but we have also this, we saw this strong collaboration around the year increase, and we know that to face the new challenges that we had, as said Dr. Phillips this morning, on the quantum technology, on digitalization, we have to continue our effort to work together, to collaborate together, and to really continue this quality infrastructure to be the best as possible to answer to all the challenges on the Metre Convention. So, Professor Alessandro, dear Alessandro, can you introduce yourself, and then I will ask you a question. So, sorry, Sharon Mayer, I forgot to introduce yourself. Alessandro, please.
I'm Alessandro De Angelis, and I am a professor of physics in Padova, and I work presently as responsible for science and technology for the permanent delegation of Italy to the international organization. By formation, I am a particle physicist. I worked at CERN for some 10 years, and then I came back to Italy as a professor, and I started working to astrophysics. And I have a hobby, I'm a scholar of Galileo. So if you have questions on Galileo later, I can answer.
So in this session, we thought important that we give some other strong example of collaboration and multilateral cooperation. So what are the primary motivation for nations to invest in large-scale big science collaboration like CERN, this was an example, or the Square Kilometre Array? So,
thank you. So I mean, I start with the CERN because CERN is a success story, but we will see that also the SKA, the Square Kilometre Array, is a fascinating story that is just starting now. And some other stories will start with the Einstein telescope for gravitational waves. The primary motivation for investing in these international collaborations is, of course, to produce science, because some problems are not at a scale that can be faced by single countries. And, but another strong motivation is to produce public goods which are not just a fallout of this organization, but at the basis of the technical success of these organizations. Probably many of you have in the memory the first image of a black hole. The black hole, okay, it was not really a first image of a black hole, but it was a picture in which you could see something that was that had the dimension of the 10 times the horizon of the events. I mean, the mysterious region that contours a black hole. And this was an incredible success, something that I couldn't imagine when I was a student. And this was produced by using the full planet as a single telescope. So if you want to do this, you need to make an international collaboration of many telescopes covering the full face of a planet, and then possibly to make the use of the orbit of the Earth. So this gives a perception of the unity of our planet, like the pictures of the Earth taken from the Moon. And it is something that we should take into account. And this is impossible without an international collaboration, and in the future we will have at least 2 sites of 1 square kilometer with radio waves, which we need to be synchronized to make a unique telescope, and possibly synchronized with other detectors with accuracies that are unbelievable. They are of the order of 1/100th of a trillionth of a second, which, by the way, is something that will be discussed later in this, because it's not far from the intrinsic accuracy in the definition of time nowadays. But the other example, as I said, is related to the production of public goods, and there CERN is a wonderful example, which is the World Wide Web. Think if the World Wide Web would have been produced by a single nation. Probably we would have more problems than we have now. So the essence of international collaboration in science is also to push technology and science at the limit, at the possible limit. Second, would say that international scientific collaboration offer a model for international cooperation in which you automatically have a decision by consensus, and consensus is not counting the votes, but it is a leadership from intellectual contribution, irrespective of hierarchy, of age, of country of origin, of gender. The agreement comes automatically when you are in a scientific organization. This is a nice thing. A third point that is present in these times is that international collaborations are an example of peace and cooperation between different countries. Like, for example, in the Middle East, there is a collaboration which is called Sesame, which has the same principle of CERN, and where all the scientists of the countries, surrounding countries, work peacefully. And when there are some closures towards colleagues, we always say that science is international. So this is a point that we want to affirm, and we are sure as scientists that this is the right way. I mean, we are sure it is the right way. As you said, Maglon, another point is capacity building, and there CERN was also a good example. And finally, the economic and technological return should be stressed. We will need more models like CERN and other organizations to tackle other truly common problems like climate change and artificial intelligence and so on, because these need a global collaboration to be solved. The last thing about this question that I want to stress is that while for other topics diplomacy has driven the organization, here it became more or less automatic to transform associations of scientists into international organizations. So there was not the need to transfer the power from the state to an international organization, but as a matter of fact, it came automatic that some organization was needed, and the model still works very well.
Thank you. Can I ask you a second question? So you said and you underlined that in support for such multilateral, multinational scientific endeavors, growing as countries recognize the importance of shared knowledge and technology innovation, like CERN. This is a very good example. Or is there a trend of waning interests? What factors influence these dynamics? And what can be learned from a recent trend in support?
Well, we presently see a mixed trend because on one hand we recognize that international organizations, in particular for science, are good. On the other hand, there are several factors that somehow push to reduce the collaboration of states and the transfers of the power from the states to the international organizations. And I see that on one hand, we are sure, that things like artificial intelligence or synthetic biology will need an overall global collaboration. On the other hand, some states show some waning interest and they push for fragmentation. Even some states that before they were pushing for open science and so on, open science is clearly the key for the collaboration, now are somehow denying the power of open science because of fear, basically. And I believe that scientists should not have fear, and people should not have fear. And we should not be afraid of things like intellectual property, because in the end, intellectual property is like the light. The light of the sun is for everybody. And so some other points that are discussed that I hear in my new job as a worker in a diplomatic delegation is that people are afraid of the cost. I believe that after the COVID, the world would have changed for the better, and we would be all cooperating for a better society, more ecological. But I was wrong. It didn't work like this. We didn't learn a lot from COVID, it seems to me. But actually, after the COVID, there were some national pressures to keep the resources. And another point is the geopolitics that is particularly complicated during these times. But I believe that the key of the political perception is the will from the people, and somehow the will of the people seems also worried by the cost of scientific organization, the fact that there are some people that are out of control of the state, while science is by definition out of control and is in control by definition. My solution to this is education. I mean, in the end, I believe that democracy should be based on education, and if we educate the people, we convince the people, also with open science, of course, we have to work and to make to understand why the money is spent. In the end, the trend will not be no more a mixed trend, but everybody will be convinced that international cooperation, also structured by intergovernmental organization, is a good thing for science.
Thank you very much. So I think, yes, we are all also aware that education and training, and that's also some important points to have a new, in the future, new meteorologists, and to support all this international organization as well. Thanks a lot, Alessandro. Now we will go to a second topic. We will discuss also of capacity building, but not only. We will discuss strategy for international organization to remain relevant and effective in the future, especially in an environment where some states may seek to challenge existing structure. We know that for all of us sometimes. So I introduce Victoria Coleman from NMI, NMIA from Australia. Can you introduce yourself, please, Victoria?
Thank you, Megalon, and happy World Metrology Day. My name is Dr. Victoria Coleman. I'm coming from the National Measurement Institute in Australia. I have a background in nanotechnology, so one of the emerging areas of science and measurement. And I'm also a member of the International Committee of Weights and Measures, which is a huge privilege for me. And in that capacity, I also have been working together with the CIPM and the BIPM on this new initiative around universal adherence.
Yeah. So yes, this is an important point that we will speak about. So you mentioned the universal adherence, and that's true that in the General Conference in 2022, the plans agreed to aim the universal adherence to the Metre Convention, and this will reflect ambition for greater inclusivity and access to global measurement framework. What are the key benefits behind these ambition plans? Victoria, what do you think about?
So we heard a lot today already about metrology à tout le temps, à tout le peuple, and I think it's really important to reflect on the fact that whilst we have the technical aspect of that covered, especially with the redefinition, which has really democratized access to the SI and to measurement standards, we now have this really important role, I guess, as an organization to think about how we can also further democratize our own organization of the BIPM. And I think that's part of the drive that we're aiming to achieve through universal adherence. So we've heard today, I think already, that we have about 101 states and associates participating in our activities, and that leaves about somewhere between 80 and 90 states in the world that currently are not formally a part of the BIPM. But I guess it's worth reflecting that, you know, we know that nearly all nations, all states are using the SI, are using UTC, and are also celebrating World Metrology Day. And we've heard also from many of the other speakers, and Sharon May in particular, about the importance of metrology and measurement to trade, to quality of life, to, you know, ensuring benefits for all of us. So there's this real drive to make sure that those states who are really interested in participating can come on board, and we will go to the next General Conference proposing a new membership category or observer status, which really hopes to bring those countries, those states into our family and further strengthen our organisation, because essentially we know that this amazing organisation that we've built essentially on consensus is really stronger when we all participate together and when we all come together. And I think after 150 years of a long history where there have been challenges in the past, I know we're also entering challenging geopolitical times again, but I think the framework that's provided by the metrology of science and being able to come together and speak a universal language and use that language to tackle some of these big challenges of our time is really important. And also, because many of those states that currently aren't participating that we really want to target with this initiative are have a low GDP, for example. Things like capacity building and knowledge transfer will be increasingly important to those states, and being able to provide a framework and a strong base within the BIPM to really leverage that multilateralism and work potentially with other international organisations to the benefit of all of us is something that certainly I'm really excited about, and I know my colleagues are also really excited for.
Yes, thank you, Victoria. And I think that this is really the spirit of the Metre Convention, to disseminate the wider as possible, and that we have all these countries who are not still in the Metre Convention, but you use the SI. It's really important to integrate, and that's I'm really convinced that. And maybe also the regional metrology organization can have also a big role in this universal adherence of country. Especially, sorry for that, but in the continent of Africa, we have really a strong need to have all these countries coming with the Metre Convention. So I have a second question, so maybe also Mr. Wu can participate. What particular step or diplomatic efforts might be necessary to overcome resistance or reluctance for some member states? How can position around shared interests and possible economic benefits help broaden international support?
So I think actually the response that we've seen has been overwhelmingly positive towards our proposal. So I don't expect too much resistance from this proposal. And sometimes, a proposal is good when people say, "Oh, that seems so obvious. Why haven't you done that already?" And I think that's definitely something that we've been seeing as we've been going around talking about our proposal. But overall, keeping in mind that focus, that really it is by coming together and working towards consensus, we actually all benefit when we're all at the table and we all can participate and bring our voice to that conversation, particularly as we enter new times of technological challenges where diverse voices are really important to bring to the seat to have that conversation with us and to participate in that environment. So I think by widening participation, more formally, and as you say, we know already many of those states are already participating through the regional metrology organisations, but to bring them under the international umbrella, to also facilitate access to other international organisations to become observers of our organisation, really strengthens this organisation for all of us and hopefully positions us really well into the future.
Thank you. Mr. Ho, you want to add something?
Yeah, thank you. And I fully agree with what Victoria already mentioned. I think really you see the metrology, as I mentioned earlier, is not only the technical field, it's really changed the society. It's the way of the thinking, is part of the culture. I can still remember, you see, in my personal experience, in my grandparents, my parents, and the new generation, and how the measurement has been changed in our daily life. When we talk about, you see, the width, the mass, and the length, and the size, the volume, and in the past, you see, the 50 years, I experienced, you see, a lot of change has been happening. So it's really changed the society. So among you see this house, definitely you see that nobody will argue that you see how metrology, the importance for the science itself, for the daily life, and for us to advance our modern, society. But I think this kind of a message we need to really be, conveyed, to out of the house, to out of our metrology, community. And like you see, for the International Day on the Metrology, and we need really, to not only celebrating within ourselves, within our community, we really need to go to the society. We need to go to the schools.
Yeah.
And we need to really engage and other different, the sectors, the societies. And that's why we say, that right now, how science can drive the policy decision making, because we face the similar problem, in general for the science. Our science community, normally, that we all can easily reach some understanding, and we all believe that, science is so important for the evidence-based decision making process. But such kind of the message has not yet been received by the policy decision makers at the different levels. At the international level, we're happy we have the IPCC, we have the IPBM, and for the biodiversity. And we have, so many mechanisms that really engage the science into the decision-making process for the negotiation. At the country level, so many countries also, they established some of the science advisory board or the office. So they advise the government how to do that. Recently, in the UN, the Secretary General also established the Secretary General's Science Advisory Board to advise the senior management of the UN. If they took decision, they should base it on the science. But for the metrology, the same. And it's really, that's why we think, science diplomacy is really the opportunity. And for us, and how we can really, engage the society, engage the different partners, is not only talking within ourselves. Of course, it's exchange idea and how we can address the new challenge, and that's very important. I'm just thinking like Professor William, what he talked is very attractive, very interesting. Yeah. Such kind of story, we can make it, maybe some small booklet, and we can disseminate it to the school and also to the decision makers, so they will understand, even to the politicians, so they will understand that we still have the big challenge ahead of us, even for the time that everybody talk about time. But nobody realized that, for the second, how we can, define the second. So that's the scientific issue, because everybody use that, they just, take it as granted. So nobody can realize it. How we can, work outside of our house and then to engage more partner, I think should be part of all the responsibility who is really engaged in the metrology, community. We do wonderful job. We know, how important, but this kind of message, how we can really get outside of this house. Thank you.
Thank you.
Magdalene?
Yes, Sharon.
Yes, I'd like to congratulate the BIPM for this initiative in establishing the observer category, which truly makes the opening for all peoples available, right?
Totally
but I also want to address the question you raised with respect to how to overcome perhaps those nations that are resistant or may be resistant to becoming observers. And the perception is that if you are not in the science discipline, when you are looking at metrology, it's not such a sexy subject. So persons may be reluctant to read and to engage, and that may be perceived as resistance. So the important thing, I think, is for us to sensitize our publics, and especially those economies that are not yet members, whether associates or other types of members. If you want to introduce them to the field, then sensitize them at their level, and especially speak to the leaders of the country, because usually the scientists will readily move towards any system that will advance science and technology within their countries. It is those that are at the leadership level that needs to be embraced and sensitized. And when that is done, then what was perceived as resistance will evaporate, and you will see that everyone wants to conform and be a part of this global corporation. Thank you.
Yeah, thank you, Sharon. I think that you are right. It's not only the public. We have to educate, of course, the people. We have the public, but we have also all the decision makers and our governments that we have to convince that metrology is essential for the society, for industry, and for innovation. So thanks for adding that. So we arrive to the last panelist, Mustafa. Please, Mustafa, can you introduce yourself with a few words, and then I will ask some questions.
Thank you very much. First of all, I would like to congratulate the 150th anniversary of the Metre Convention and Happy Metrology Day. As you see, all the speakers say a lot of good things for the capacity building. How is the metrology important? I am fully agree with them, and I try to give some contribution also.
So please, Mustafa, you are the director of TubiTech. You may. I will ask you some questions.
Yes, please.
So, given the evolving landscape with specific action, such as expanding capacity building efforts, and I think that all the regional metrology organizations and BIPM are doing that, developing new measurement techniques or fostering greater stakeholder engagement, should international organizations prioritize?
Okay, thank you. Let's take a look at what we have been dealing with in metrology. In the last decade, besides classical methods, quantum metrology, digital transformation, artificial intelligence, biometrology, etc. The scales we have been working with the range from femto to peta. I mean, from 10 to the minus 15 to 10 to the plus 15. While we currently describe the scale from the questo to quetta in the SI brochure. I mean, from 10 to the minus 30 to 10 to the plus 30. These are really needed in the nowadays priority areas such as space, aviation, defense, security, health, environment, that are defining the targets for metrology. There is no doubt that the development of new measurement techniques and measurement standards in line with the demands for developing technology worldwide should be a priority activity for the entire metrology world. However, since the leadership of international organizations, I mean here the BIPM, and their activities in the relevant fields will require serious financial and human resources in order to meet all needs. It would be more appropriate for the BIPM, for example, to prefer the coordinated scientific and technical studies carried out in international organizations in different countries all around the world. So, IOs should first determine their strategies. While developing the strategy, the inclusion of all relevant parties, I mean, in other international organizations, users, standardization entities, should be ensured. In this case, fostering of the stakeholders' involvement will be actively realized in the development of these strategies. And stakeholders will be informed about determining needs and techniques, methods, and other issues that need to be developed. I mean, raising awareness should be achieved. In addition, for the metrological facilities, international organizations should prioritize the training for human resources and capacity building activities. In particular, the organization of summer schools and settlement programs and the expansion of their scope are indispensable actions. In this context, close cooperation with the universities and educational institutions and the opening of new training programs are other issues that must be insisted on. Activities that help increasing awareness should not be forgotten either. For example, actively communication with the stakeholders and users by making use of media and organizing different events such as congress, workshops, info days, and etc. are obvious examples of the awareness activities. However, international organizations do not need to carry out all technical activities themselves. And this does not mean that they should be completely away from the technical activities, of course. In some technical areas, especially in selected areas, such as cable balance, like BIPM, and within their own organization, scientific activities should be carried out. In general, I want to point out this in response to your questions. Thank you very much.
Thank you, Mustafa, for that. Yes, we understand that communication is essential as well. I think that quite a lot of NMIs has already some strong relationship with academia, with university. But the point that you raise on to have really stakeholder on board, this is really essential, that for each country that we know exactly what are the needs of our society or our stakeholders, and that we really answer to that. And of course, we have also to train people as well. Are you ready for a second question, Mustafa, or no? No, just it's, we know that in Tubitak, you have played a really active role in capacity strengthening. What do you think that are the crucial gaps in current initiative, or your point of view in your country?
First of all, I would like to give brief information about what we as Tubitak UME do in supporting capacity building and knowledge transfer in the world of metrology. Firstly, we have one-to-one collaborations with NMIs from more than 90 countries so far. And the majority of these efforts are aimed at increasing their metrological infrastructure and measurement capabilities. Secondly, our institute provides strong support to capacity building initiatives in cooperation with the BIPM, as well as within the different regional metrology organizations. And mainly through the Euromet and GovMet. And the most important program where our institute put a lot of effort is the Tubitak UME project placement program with the BIPM, which allows young researchers from various designated institutes and NMIs to work in Tubitak UME's laboratories on different tasks on a free of charge basis. So we started with this action, very basic trainings, 8 years ago. And currently, the program has reached a much higher stage, such as researchers from other institutes work on particularly focused subjects, like research on quantum standards, artificial intelligence in metrology applications, production of reference materials. Up to now, we have received totally 429 applications from 33 different countries in 7 cycles since 2018. Unfortunately, in each cycle, in each year, we can host only 10 researchers. The magic number 10 is due to the limitation in our guest house number.
Very nice guest house.
Thirdly, Tuvitokume led the Metrology Council of CIMIC. CIMIC means the Standards and Metrology Institute for the Islamic countries, since its establishment till last year, 13 years. In this period, we had also given huge support to increase the metrological capacities of the member states. For example, we trained 593 persons from more than 30 countries as free of charge also. So global capacity building on metrology should be supported because it is necessary and important for all members, especially for observer studies, to more diverse stakeholders, or also for the new countries. Thank you.
Thank you, Mustafa. Yes, I think that Turkey has been very active in capacity building. And of course, within also Euramet, you have been participating to many activities. So thanks for that. So I think that we arrived to the end of this session. And I think that it's important that maybe we try to have a financial statement. So I would just say that international organizations like BIPM give really a hope for a better world. And we have this, we hear that from this morning many times. I think that it also shows that people can do, when they work together, they really do the best and to advance science and society. And this is important, and metrology shows that for the 150 years up to now. This has been this 150 years history, and I'm sure that we have more adventure and we are already on the way. So who would like to give also some final statement for strong statement? Victoria, you want to start?
Sure. So thanks, Megalon. I guess my final takeaway would be just reflecting on the fact that metrology at its very heart is a science of consensus and collaboration across borders, and that survived through the whole history of the treaty, but is, I guess, most well demonstrated by the redefinition in 2018. And it's really important that that collaboration continues and that we continue to hold the BIPM as that organisation of reference that is so critical to supporting science and innovation across the globe as we move into the future. Thanks.
Thank you, Victoria. Sharon Mae.
Thank you. The BIPM has had a rich legacy of cooperation over the 150 years. And Professor Phillips did a great job in summarizing the work of the BIPM over these years, well, from when he picked up at his point, yes? But we want to see that 150 years hence, that the BIPM's legacy will continue, that the cooperation that has been established internationally and that we have seen regionally, we have our different metrological regional institutions, we have SIM for the Americas, and we have smaller corporations like the Caribbean Corporation through CARICOM and CrossQ. But we want to see that our associate members in the BIPM, that they have greater opportunities to participate and to be at the table. Yes, we are there and we are benefiting from the knowledge transfer and capacity building programs that have been quite effective. And I know there is a willingness from all the presidents to support developing economies, and especially small regions like the Caribbean. But we want to be more actively engaged. And I don't know how you will do it, but I challenge you to do it. It's not just what can be done, it's what we should do to make sure that the voices right across the world are mentioned or referenced at the table, the important decisions and discussions that are held. So I challenge you to do that, because ultimately we want at the end of our tenure in whatever organization, international organizations right across the world, that when we are weighed and measured in the scales of life, we will not be found wanting. I know the BIPM in another 150 years will not be found wanting, but you will have advanced the issue relating to time that challenges us now, and that there will be much more that you will be contributing to our development and our growth as we look at AI and we look at IoT and we look at all of the new technologies that are emerging. So we thank you for what you have done, BIPM. We congratulate you for the legacy that you have, but we challenge you that there is a little more that could be done. Thank you.
Mustafa, you want something?
With your permission, also, I would like to give some contribution for the capacity building.
Sure.
For especially
You're welcome.
why the metrology and why the BIPM is so much important. Why we have to support the BIPM. So, first of all, the well-developed national metrology institutes should provide cash and kind support to the BIPM capacity building and also knowledge transfer first. Financial support from external donors is inevitable. And in my opinion, the most important thing for the achievement of reaching to the desired target is to explain the economic impact of the metrology to the decision makers at high level. For this, I would like to make a suggestion to both the BIPM director and CIPM president, with your permissions. My suggestion is to organize a special season about the economic impact of the metrology at the next CGPM meeting. I don't know why, but maybe it will be very, very beneficial. And actually, no matter what, the global metrology system, for many reasons, need the existence of BIPM, which was established with the world's second oldest international agreement. And hence, I especially request from the most advanced NMIs to give maximum support to BIPM, not only for the capacity building and knowledge transfer, but also for every metrological activities. Through the program we carry out with the BIPM together, I personally witnessed how admirable it was that the BIPM managed to remain equally distant to all its members. Despite various geopolitical circumstances around the world, but unfortunately, we have not always seen in the regional metrology organizations. And therefore, the BIPM must continue its work, as it has done for the past 150 years, as long as global trade exists. And we must all do our utmost to support the BIPM so that it can serve the world metrology system even much better. Yeah, thank you.
Thank you a lot, Mustafa. So, Alessandro, Xiaofeng, do you have a final statement?
Yes, I'm really pleased. I must say, okay, this will be... I'm following several organizations, but BIPM is really the best. Because, first of all, the long life of BIPM is not coming from an accident. It is due to the fact that BIPM is adapting very fast to change. For example, I didn't see in other organizations, and I worked a lot at CERN, a so fast adaptation to the trend to digitization, for example, which is also a trend reducing the costs. I also never saw such a community agreeing for the common goods and the common share of open science and open results, and availability towards among different countries. And the institutional flexibility is the key probably for the development of the future of international organization. And in this sense, the work done by BIPM in the first 150 years is clearly an example. The task of BIPM is difficult because it involves a shared language which is at the basis of not only of science, but also of trade, of health, of innovation, of fields that acquire a different relative weight depending on the period and on the tendencies of the population feelings. And BIPM is faced very well the time of climate crisis and the consequent reactions by different communities that were difficult and in some countries very critical. And providing a reliable metrology for all is not an easy task, but it is a task that is needed if we want to build a common world, and we don't want to avoid in the problems of the Babel Tower. This was said this morning, and the future of the global coordination starts with a common measure. So happy 150 years and happy new 150 years.
Thank you, Alessandro. Mr. Xiaofeng.
Thank you, and I think you see, I just have one, you see the message that you see really the International Decade of Science offer the platform for enhancing global measurement infrastructure and for sustainable development. So I really invite all of you to really go to our website to take the look of what you see the Science Decade and to explore the opportunity and to work together globally so we can, you see, bring the measurement to the next phase of this development. Thank you.
Thank you very much. So we arrived really to the end, so I would like to conclude with a word who has been given by Philippe Taquet, who was the former president of the French Academy of Science. And I think that this summarizes quite well what is BIPM. BIPM is an organization that is a perfect and magnificent example of a work of peace. It symbolizes in a unique manner what people are able to achieve when they pool their wills, their knowledge, their talents, and their abilities. The BIPM was a precursor, and I think that we hope that it will continue for the 150 year next year. Thanks to all of you. So thanks to Victoria, Sharon Mae, Mustafa, Alessandro, and Xiaofeng. Thank you to your attention.
Thank you so much, Magdalene Chambon, and all of the panelists. Please do take a moment to find your seats. As you make your way off the stage, I just really want to say how much I appreciate you breaking down just the stakes of international collaboration and also that challenge that was thrown out by Dr. Smith Walker to, as much as we appreciate how much has been done by the international community of metrology, to continue work on widening that circle and expanding the range and kinds of conversations that are being had. Well, before we move on, time for a change of pace. You know, we just heard so much about collaboration, precision, range, and so much of the principles at the heart of metrology are behind experiences that universally move us, like music. So with that being said, I will now hand you over to Malik Dior Band for a short interlude. Messieurs.
sañoon ñun ñu ànd bala ma sañoon ñun ñu ànd bala bala mooy doole loolu mooy li waaw bala mooy doole soo woow li ma gis ci réew mi jaaxal na gis sa nawle mu liggéey ba dëkki nga ne naa ko yàq ba mu jaar fa walla kaana na mu def ba mel ni soo ko defee dëkki waaye soxor tax na nga bëgg ko yàq oh yéeme na si ñun lu ñuy dundee oh yéeme na oh yéeme na si ñun lu ñuy dundee oh yéeme na liggéeyante bee yàqalante bee hërëmante bee daf ñuy fewale suma sañoon ñun ñu ànd bala mooy doole loolu mooy li war bala mooy doole
Merci beaucoup, Malik Dio et Abdou Koyate. So I think I'm not alone in saying that the morning's got off to a pretty good start, and I think we've earned some lunch. So please do make your way out of the hall. We hope you enjoyed the packed lunch that have been set out. Mingle, chat, network, blue sky, exchange your aspirations, inspirations, ideas that have been sparked by this morning's conversations. But please do keep an eye on the time. I would ask you to be back in your seats, or at least close to grabbing them, by about 2:20 this afternoon, so that we can start the afternoon session promptly at 2:30. So 2:20, come back and kind of hang around. Bums on seats by 2:30. Thank you so much for being with us this morning. I'll see you shortly. Have a lovely lunch.
sanana, aye baba, so sanana. Oh mama, mama you amo you didn't know. Oh mama, suma degule semaine, mama, suma degule de semaine, mama. Lagi baman wete kumamu kuasa jande, patak sama dong di momi di jama ayaya. So sanana, aye baba, so sana. Oh mama, mama you amo you didn't know. Oh mama, suma dekule semen mama. Suma degule de semaine, mon woman. Très pas mal, où est-ce que mon coin se jamne? Pas d'argent, madame, qui m'en vient de yama. Aïe, aïe, mama, mama, oh, mama, mama, yeah, mama, mama, oh, mama, mama, yeah, mama, mama, oh, mama, mama, yeah, mama, mama, oh, mama, mama, yeah, mama.
Amadou Kouyate. Now, welcome back, ladies and gentlemen. I hope you had a lovely lunch and or enjoyed the sunshine or some of the amazing exhibitions that I quickly passed on the way in for Africa Week, which is a lovely crossover. But with regards to why we are here, so stepping back into history isn't a ramble, it's a workout. A fun one, I promise, but it is really to appreciate how far one has come by retracing steps to really break down what it took to get you where you are today. So today is a celebration, but it's also a chance to spotlight and appreciate what worked and maybe repurpose it to keep driving us forward with the same energy and vision and unity that yielded the Metre Convention in 1875, which blossomed the BIPM and the metric system and the evolution of all that it has birthed to meet the needs of science, industry, and communities around the world. So for this afternoon's historical workout, it is my pleasure to hand you over to Dr. Fabienne Cassoli for the first session. Doctor.
Ladies and gentlemen, distinguished guests, dear colleagues, Your Excellencies, it's a pleasure to chair this session and the panel discussion about 150 years of international use of the metric system. This invitation honors my institution, Observatoire de Paris. Indeed, as we will hear from the first speaker, the first definition of the meter as the 1/10 millionth of the distance between the pole and the equator is based on measurements of the meridian conducted from astronomers at Observatoire de Paris since its foundation, and especially the measurements made over 7 years during the French Revolution by astronomers Delambre and Méchain. This meridian Paris goes all through the Observatoire de Paris in the middle of our historical building. As the unit of length, the meter, you have been told this morning that it is defined by taking the fixed numerical value of the speed of light in vacuum. And the first demonstration that the speed of light is finite was published by the Danish astronomer who worked in France at that time in Journal des Savants, the Journal of Academy of Science in 1676, based on observations of the satellites of Jupiter made by himself and Picard at Observatoire de Paris. Nowadays, metrology of space and time and frequency is always a central activity in Observatoire de Paris. We are in charge by decree of producing and disseminating the French legal time. And I must read it. This decree from it was from the version for 2017. The first line of the decree is vu la convention du mètre signée à.
Taking into account the Metre Convention signed in Paris in 1875.
Dans le cadre de la coordination.
In the framework of the coordination of the rules as established by the International Bureau of Weights and Measures for the establishment of the Universal Coordinated Time, the Observatory of Paris is responsible for the dissemination of such information.
Paris, a lot of our work is under Convention du Mètre and under BIPM. I must say also that our atomic clock makes a strong contribution to the International Atomic Time, and we are making a lot of research to improve the standards and our clocks. And I'm very proud that we are part of the experiment that has been sent to International Space Station, ACES. It has been sent 4 weeks ago, and it composed of two clocks, and one of these, Pharaoh, is very dear to our teams. It's called atom clock. However, I must confess that in general, astronomers have a distant, complex relationship with the metric system. This may be due to the huge range of distances, times, and masses that you encounter in astrophysical context. We use to measure the distance from the planets to their host star, use astronomical units. We could have used gigameters, but we did not. And the distance to external galaxies is given in megaparsecs or gigaparsecs. We use magnitudes, a logarithmic scale, to measure the brightness of astronomical objects in the visible and infrared domains. But radio astronomers, you know, it's like when you had different units to measure the same thing in distant towns, even close towns. And here you have the towns of optical astronomers, they use magnitudes, and then you have the town of radio astronomers, they use Genskis. And sometimes it's very difficult to understand each other. I hope sometimes it will improve. Despite this somewhat ad hoc use of the metric system, astronomers are well aware that a common system of units is essential. They all remember the famous loss of Mars Climate Orbiter, this robotic space from NASA, who was lost in 1999 because it encountered Mars in a trajectory that brought it too close to the planet, and it was destroyed in the atmosphere. The investigation attributed the failure to a measurement mismatch between two measurement systems, the SI units, metric by NASA, and the US customary units by the spacecraft builder, of which I will not be giving the name. This was really a stupid tragedy. I've been personally involved in a NASA Mars mission called InSight, which in 2018 landed a seismometer on the ground of Mars. The industrial prime contractor of the InSight mission was the same as that of Mars Climate Orbiter. And believe me, from the very beginning of the mission in the years 2010, it was decided that everybody from the industry in the US to the instrument providers in France, but also UK, would use SI unit. And this was checked several times. However, if you look at the NASA communication to the general public about InSight, they still use both systems of units. Before this brief introduction about astronomers at the Observatoire de Paris, I think we will have a short video to set the scene before I call the first speaker.
I cannot imagine the researcher of this 18th century coming now and see what our society developed because of this measurement who are unified and used by everybody.
Thanks to the metric system, science, trade and innovation found an universal language, one that speaks in meters, kilograms or seconds, making global collaboration seamless. From building rockets to measuring medicine, the metric system unites us in accuracy and precision. It's not just a system of measurement, it's a system of progress, because when we all measure the same way, we move forward together.
Imagine that all the country, or practically all the country, even they are not in the Metre Convention, they use this metric system. And more than that, it's also a decimal system. What this means is that they can use it for example, for the meter, for the nanometer to 1,000 of kilometers, and also for our daily life to go from one place to another one for some kilometers. So that means that this is used for scientific purpose, for industrial purpose, for societal purpose, for your medicine that you will take every day in a pharmacopoeia, or for to fulfill your gasoline in the car, etc., etc.
Such a system supports transnational manufacturing. It guarantees the equity and the efficiency of global trade. It facilitates scientific collaboration. It enables, underpins, and drives globalization, which all of us is benefiting. Responding to the evolving needs of metrology needs more global collaborations than ever before.
The SI underpins international trade,
and commerce, underpins legal metrology. It provides the basis for product testing, health and safety, accreditation system. It's been a great joy and a great pleasure for me to have been associated with metrology, to be a metrologist.
So we have three panelists in this session. The first one will be Professor Alder, which will give us a keynote address. The second speaker will be Dr. Duan from the National Institute of Metrology in Beijing. He will be in video conference, I think. And then the last speaker will be the director of the BIPM, Dr. Martin Milton. If we have time, we should have a session of questions and answers from the audience. So be prepared. Prepare your questions, your burning questions. We should be able to take a few questions. So our first speaker will be Professor Alder, which is Professor of Humanities of History at Northwestern University. And the central theme of his work is the history of measurement. I think that's a good subject for this audience. Both of nature and of human beings, and the many ways in which quantitative values reflect social values. Ken Alder's second book, The Measure of All Things, examined the origins of the metric system in revolutionary France. This book has been translated into 12 languages and won 3 Best Book prizes. He also won a prize for traduction for the best translation in France. He has also published books on the origin of modern engineering in the French Revolution and the history of America's obsession with the lie detector. Very interesting portfolio. So I now call Professor Alder, if you want. The scene is yours.
Bonjour, Monsieur et Mesdames.
Ladies and gentlemen, hello, good afternoon. Welcome to this afternoon session for World Metrology Day and this a special birthday for the Metre Convention. I am going to give my speech in English, even though most of the Metre Convention's history happened in France and in French. It's an honor for me to be here with you.
To the afternoon sessions of our gathering today. We assembled today to honor the 150th anniversary of the Metre Convention of 1875 and the founding of the Bureau International of Poids Mesure. It is fitting that we are holding this convention in its honor because it is a convention that we honor. That's more than a pun. As I will explain in my remarks today, it is only when we gather, when we meet to iron out our differences, that we are able to forge the kind of consensus that makes metrical conventions, metrical standards, stick. It's true that the organizers of such conventions tend to hold them in beautiful settings, in Paris, for instance, which has seen its share of such gatherings. This has sometimes led skeptics to dismiss these assemblies as boondoggles or junkets or empty formalities, but this is to misunderstand their value. Such agreements have a long history and serve an essential and noble cause. The history of standardized measures begins in the early 21st century. That's the 21st century BCE. When the world's oldest surviving law code, the oldest law code of which we have a record, the Ur-Nammalud Code, was promulgated in Mesopotamia 4,000 years ago. The code opens with a preface which invokes the gods and praises the king for establishing equity throughout the land. And how had the king ensured the fair administration of justice? According to the preface, by standardizing the kingdom's weights and measures. Not only had he defined the mina as the realm's unit of weight, he divided the mina into 60 shekels so that its weight in silver could serve as a currency. He also set the standard silo, ration bowl, as compensation for a day's labor, and extended this quantitative logic to the rest of the laws. No longer was punishment to be meted out an eye for an eye. Henceforth, it would be a half mina for an eye. Just measures would guarantee equal justice. As the preface concludes, the orphan was not delivered up to the rich man. The widow was not delivered up to the mighty man. The man of 1 shekel was not delivered up to the man of 1 mina. The problem, of course, was this royal decree, like those which followed, did not endure. Our standards of measurement define who we are and what we value. We speak their language whenever we exchange information with precision or trade objects with transparency. To do their job, standards must operate as the shared conventions against which we strike agreements and make distinctions. This very ubiquity, however, tends to make measurement invisible. People generally consider measurement banal and only notice measurements when the standards themselves vary by time and place. This was certainly the case in old regime France, when under the cover of about 800 different names for units, there were in fact 250,000 different units of weights and measures in daily use. As Professor Phillips pointed out, they tended to be physical objects located either in a church or a manor house or a guild house, and they differ from town to town and from profession to profession. Sometimes it's really true that a pound of feathers might weigh less than a pound of lead. Some of these other measures, though, served a very important social purpose. They regulated local trade and custom. For example, there was a measure of cloth that was the width of the local looms. Or fields were measured by what we would call volume, by bushels of grain. How much grain did it take to sow that land? Or vineyards were measured in days. How many days would it take to pick the grapes? This diversity preserved local control of trade and norms of labor, but it baffled travelers, stifled long-distance commerce, and frustrated the equitable administration of the state. As one Englishman traveling the countryside of France remarked on the eve of the French Revolution, the infinite perplexity of measures there exceeds all comprehension. That is why, on the eve of the French Revolution, when the French people were asked to list their grievances in the famous Cahier de Doléances, thousands of French municipalities asked their leaders to create a uniform set of weights and measures. The challenge for the National Assembly then was, what sort of uniformity would they create? The French Revolution may have begun as a national revolt, but its leaders had universal aspirations. While some legislators did want to impose Parisian units on the nation, the creators of the metric system proposed a different solution. Instead of measures valid for a single nation, they would turn to nature, which was the same for all. After consultation with members of the Academy of Sciences, they defined the meter as 1/10,000,000th of the distance from the North Pole to the equator. And you may ask why that particular definition? Well, it's because it came out about that long. They did want a unit that was on the human scale and very close to an old definition of actually a width of cloth, an un. As Condorcet put it, and as the motto of this conference proclaims, the new measures would be pour tous les temps, pour tous les peuples, for all time and for all people. And so the French authorities reached out to other nations to help them in this project. Unfortunately, the revolutionary wars of that era ended all talk of collaboration, and it was France alone which dispatched 2 astronomers to perform this task. In 1792, Delambre and Méchain were sent north and south respectively to measure the length of the meridian arc that runs from Dunkirk to Barcelona with the goal of extrapolating from that distance to the full quarter arc by measuring the latitudes of the two endpoints. So this is the triangulation that they made of France in the era. The larger section by Delambre had been measured in the past, and so it was the longer one. The southern section, which had not really been measured before, was given to Méchain. It was a mission of awesome responsibility. In June 1793, Antoine Laurent Lavoisier, the founder of modern chemistry and actually the chair of the Academy's Committee for the Reform of Weights and Measures, wrote to Méchain, then surveying in the south. He wrote, this is in French, but I will read in English, "You must not forget that you are carrying out the most important mission that any man has ever been charged with, that you are working for all the nations of the world, and that you are the representative of the Academy of Sciences and all the savants of the universe." Talk about shifting the burden of Atlas onto someone else's shoulders. For the next 7 years, the two savants surveyed the territory, slowly measuring their way towards one another. They climbed cathedral towers, volcanoes, and fortresses. They crossed battle lines, survived life-threatening injuries, and were threatened by peasants who mistook them for spies or land surveyors, which is, in a sense, exactly what they were, until at last they returned to Paris to present their data to an international scientific conference of the most illustrious savants of France and its allied nations, who together calculated the length of the meter. In 1799, this calculation was embodied in a platinum étalon, a standard bar, which then became the world's first universal standard of measurement. Over the next decade, their achievement was then written up by Delambre in his book Base du système métrique, which you see here, and accepting a volume of this book in 1806, Napoleon Bonaparte, by then Emperor of France, declared, "Conquests will come and go, but this work will endure." Or so the familiar story goes. Indeed, you can see here on the title page of Delambre's own copy of his own book, he had written in the margins there these words of Napoleon. That's how we know they were said. And that book somehow, this particular volume of this particular book actually left France 100 years ago under somewhat mysterious circumstances and ended up in a private museum in Southern California, where I finally tracked it down. And in the margins of the book, I found not only this comment, but many other comments. Many other changes in the data, many other corrections and addendum, including a note from Delambre indicating that he had placed the records of the metric expedition, his own logbooks, as well as those of Méchain, on deposit in the archives of the Observatoire de Paris, just in case anyone wanted to verify his account. Well, history, like the natural sciences, is a discipline based on empirical research. So I decided to visit those archives to see what they contained. That's where they are to this day. Delambre's notebooks, I discovered, are classics of their type. Bound volumes, numbered pages, written in ink, signed and dated at the bottom of each page. Méchain's logbooks, however, look nothing like this. They consist of loose leaves of paper, written in pencil, unsigned, often undated, then pasted by Delambre into a larger logbook where he retraced them in ink and provided annotated comments. And at the end of one of the last of these collage notebooks, I found this note by Delambre. I will read in English. "Because I have not told the public what it does not need to know, I have suppressed all those details which might diminish its confidence in such an important mission, one which we will not have a chance to verify. I have carefully silenced anything which might alter in the least the good reputation which Monsieur Méchain enjoyed for the care he put into all his observations and calculations." Well, what details had been suppressed? Why silence anything which cast doubt on Méchain's measurements? The answer lay in other documents in the archives, letters between Delambre and Méchain, letters which Méchain had begged his colleague to burn after his death, letters which Méchain had instead placed under seal. Méchain was the son of a plasterer from the town of Laon, who had by dint of meticulous labor become a naval cartographer and a comet hunter. He was a cautious man, a family man with 3 young children, and his scrupulousness was born of self-doubt. Méchain had begun his expedition by measuring his way south from the Pyrenees to Barcelona, where he spent the winter of 1792 measuring the latitude of the city by taking 10,000 observations from the fortress of Montjuïc. This work done, Méchain mailed his data to Paris and was preparing to return to France to measure the triangles there when 2 disasters struck in quick succession. First, war broke out between revolutionary France and royalist Spain, and the Spanish authorities forbade him to leave the country. And then second, he suffered a freak accident. He was visiting a mechanical pumping station, and he was literally struck in the chest violently by one of the arms of the machine. It sent him into a coma for 3 days. He suffered massive injuries, and he went to convalesce in a hotel in the center of town. But to prove that he was still being useful to the project, he decided to confirm his previous measurements of the latitude and took another 10,000 measurements from the courtyard of his hotel. Imagine his horror when he discovered a discrepancy greater than he could account for even after correcting for the distance from Montjuïc to his hotel. How could he return to France and say the meter might be this or that long? Already back in Paris, several illustrious savants, Lavoisier among them, had been executed by guillotine. So Méchain made a fateful decision. He decided to suppress the second set of data and keep the knowledge of the discrepancy secret. Then abruptly, Spanish war policy changed, and he was forced to leave Barcelona and return to France. But there, the secret discrepancy began to torture him. He slowed his labors, making almost no progress on his triangles. His letters became melancholic. Several mentioned suicide. He took refuge in an abandoned monastery in the Montagne Noire and refused to continue the mission. Back in Paris, Delambre and his colleagues tried desperately to get him to finish the expedition, until at last they hit upon an ingenious solution. They sent his wife down to fetch him. This, though, was a brilliant move because Madame Méchain was an incredibly competent and skilled astronomer herself. In fact, she had done all his continuing observations at the observatory while he was away on mission and continued to get paid in his name. And in fact, this was a very common practice in the old regime. Many of the operations of science were family businesses, and alike, just like being a goldsmith was. And the entire family was involved, though the man would get credit as the public figure, no surprise. The women as mothers or sisters or daughters did much of the labor and contributed enormously to this project. There were more women scientists, you could argue, in the 18th century than there were until the late 20th century. And in fact, that's not just in proportion, that's even in absolute terms in certain fields like astronomy. Something to think about. The professionalization actually in the 19th and 20th century largely excluded women until much, much later in the century. So though her name does not appear anywhere in the logbooks, it is Madame Méchain who helped complete the meridian triangles. When Méchain returned to Paris, though, he still hadn't told a soul about the unreported data from Barcelona. I think he told his wife, and he told one astronomer in Italy, which is how we know about it at the time. Extracting uniformity from nature, as I don't need to tell this audience, is no simple task. And enlisting other nations to join in that common endeavor can be more difficult still. The happy paradox is that the solution to these two problems go hand in hand. Collaboration turns out to be the best assurance of reliable metrology, and reliable metrology is the best inducement to collaboration. For the past 150 years, the Bureau International des Poids et Mesures has labored to bring this dual project to fruition. The seeds of that project were planted at the world's first two international scientific conferences, both devoted to creating the metric system in the first place. The first took place in 1798 in the little duchy of Germany, Duchy of Gotha in Germany, where a dozen European astronomers met to calibrate their instruments, and here the French astronomer, Joseph Jérôme Lalande, preached the virtues of the metric system. They also took in an excursion to the residence of the Duchess, where they drank champagne, danced till dawn, and fired several cannon which shattered the windows of the chateau. And here you can see Lalande and his illegitimate daughter, who was the workhorse of his very famous career as an astronomer and did much of the calculational work on his behalf and all the organizing of the conference. The second conference was far more consequential. Later that year, the French government invited a dozen of their allied leading scientists to Paris so that the astronomers from Denmark, Holland, the Italian states, Spain, and Switzerland might work alongside their French colleagues to convert Delambre and Méchain's meridian data into a single value for the meter. It was this assembly of savants which discovered another discrepancy. As the great physicist Enrico Fermi would say, many years later, obviously, if you make a measurement and it confirms your theory, that is nice. But if it disagrees, then you may have made a discovery. The expedition's measurements had led to a discovery, to two great discoveries, in fact. The first was that not only was the Earth not a sphere, as the savants knew, and flattened at the poles, as they already knew, they now discovered that its eccentricity was itself variable. Indeed, the figure of the Earth was not even a curve of revolution. Each meridian was irregular in its own way. This was a new discovery, albeit one which Laplace had hypothesized about before the mission, and the finding gave birth to the new science of geodesy. There was just one problem. This discovery invalidated the core premise of the mission. Because each segment of the meridian had a changing curvature, it was not easy to extrapolate from the French sector to the whole. So after considerable debate, the savants assembled in Paris agreed to incorporate 60-year-old data from the Condamines expedition to Quito, Ecuador, which had measured the Earth's curvature at the equator. Together with Méchain's discrepancy, the result would be that the platinum bar that they created was short by 0.2 millimeters, or the width of two pieces of paper. And it was important that they discussed it, that they disagreed, that they calculated together, and that they coordinated. Because in the end, as Professor Phillips said, this in the end was an artifact. It was a bar that they were in the end creating. But they had to agree about how long to make that bar, and it was the fact that they had the discussions that made that agreement possible. But Méchain, racked with secret guilt, decided to take a second expedition. The idea was for him to extend the meridian measure south of Barcelona to the Baleares Islands and leapfrog past his original readings at Barcelona. And again, everything went wrong. Méchain died of malaria on the Valencia coast in 1804, and only then did his notes and missing Barcelona data find its way back to Delambre, who now faced a decision of his own, whether or not to publish the data. But by this time, Méchain had a new tool to comprehend error, which was the second and even greater discovery due to that assembly. The expedition's attempt to reach a new level of precision prompted the creation of a radically new way to handle scientific data. Among the academicians at the Paris conference was the mathematician André-Marie Legendre. He had been worrying about the data ever since. He and his colleagues had calculated using different techniques, but he couldn't tell for sure or make a clear distinction between how much of the discrepancy was due to observational things, or how much was due to calculational differences, or how much was due to the actual lumpiness of the Earth. Legendre's solution of 1805 was to just suggest that the most plausible curve was the one that minimized the square of the deviations from that curve. In the hands of Laplace and Gauss, This least square method soon became the foundation of modern statistics, a new way to manage error by calling the solution the equation which best fit the data. By 1810, when Delambre published the final volume of his base, he was able to use these new discoveries to explain what Méchain had hidden. For Méchain, precision was an obsession because error represented a moral failure. His honor and his reputation depended on getting the exact result. In that sense, Méchain was not a scientist in the modern sense of that term, but a natural philosopher or a savant, like Newton in the 17th century. And I don't mean to disparage by any means their accomplishments, but it is a different concept of how you do, I think, science than the one that you in this room share today, because that's quite different from how we understand our task. Delambre was a rag merchant's son from Amiens who had begun his study of astronomy quite late. He had smallpox as a child that had blinded him as it could do, but he slowly recovered his sight, which is apparently one of the natural histories of that disease, and he had risen to become the permanent secretary of the Academy of Sciences. Delambre understood that discrepancies of this sort were an inevitable part of observational science, and the goal was to minimize and explain them. In this sense, the study of metrology and the international conference which debated its findings inaugurated the modern form of science we know today. To be sure, the attendees also attended gala dinners and enjoyed the amenities of Paris, and at the end of the stay, they held a public ceremony to inaugurate the newly forged platinum bar, which would henceforth define the meter. Each delegate then returned to their homeland with an iron copy of that meter bar to tie their people together with fraternal hands. Unfortunately, once again, war then raged across Europe, and Napoleon, who had welcomed the metric reform, abandoned it. Several decades would pass before France and its neighbors, Holland, Belgium, Switzerland, returned to the metric system. The big push for international measurement standards began in the 1860s, when geodesists realized that the platinum meter bar of 1799 was insufficiently precise to coordinate their findings. This was the golden age of international scientific conferences, when nations began to find it in their interest to collaborate on problems that transcended boundaries, like postage rates, timekeeping, statistical norms, and scientific research. And the surest way to forge agreement on common rules, they discovered, was to argue things out in person. Assembling people proved essential to assembling norms. Scientific conventions require scientific conventions. The most famous of these meetings began in the midst of the Franco-Prussian War of 1870 and culminated in the Convention du Metre of 1875 and the founding of the Bureau International des Poids et Mesures. This is the event we're celebrating today. It is a history of patience and exactitude, of collaboration amid conflict. It is a story of how an institution born in the shadow of war has enrolled nations in a common project. It is a story of how the newly unified countries of Europe, like Germany and Italy in that era, found it more politic to adopt measures which belong to no one because they belong to everyone. And how the same logic then applied to countries newly liberated from colonial rule in the Americas, and countries which overthrew their own old regimes in Asia and Africa, and countries founded in the dissolution of empires. Even the United States, my home country, the last holdout against the metric system, was an initial signatory to the convention, and in fact, the metric system remains the legal standard there, even if the so-called imperial units are still the ones in common use. But the process of setting standards has never been easy or rapid. Precision measurement is toilsome work. It requires meticulous labor in laboratories mostly invisible to the general public. And the process of negotiating public agreement on such standards is also fraught and laborious. This labor, however, is what makes their resolution reliable. If precision is a virtue, that is because it matches technical exactitude to human coordination. For 150 years, the BIPM has married international collaboration to reliable metrology and reliable metrology to international collaboration. Doing so has involved myriad international meetings with repeated discussions and disagreements, plus the collegial sociability which makes consensus possible. The result has been perhaps our single most enduring monument to human collaboration. So, in the end, Napoleon was right. Conquests will come and go. This work will endure. Thank you.
Thank you. Now we should have the second speaker online. Dr. Duran, do you hear us?
Yes, I'm here.
Thank you. Thank you for being with us. So Dr. Duran is from the National Institute of Metrology in Beijing. He received his PhD in thermal energy from Tsinghua University in Beijing, China, and he was deputy director of NIM, Beijing, where he is also the secretary of the party committee of the NIM. He has a deep experience in metrology studies and strategic research, published dozens of academic papers, was awarded many prizes, and was main contributor of many scientific projects at international level. He has served as IPM member until 2023, and he also served as CCT, Consultative Committee for Thermometry, as president from 2012 to 2024. Dr. Duran is going to tell us a story not of 150 years, but a much longer one. So, Dr. Duran, the floor is yours.
Okay. Thank you, Chairs.
Thank you.
Thank you. So, good afternoon, distinguished guests and colleagues. Thank you for the invitation of BIPM, and I'm honored to have this opportunity to make a presentation on the historic contribution of China to measurement science on this Metrology Day for the 150th anniversary of the Metre Convention. The development of measurement in China from ancient time to the present has gone through the stages of emerging of the measurement concepts and tools, unification of measurement standards, systemization of measurement, and engagement in the global measurement community. The most important historical event in ancient Chinese measurement was the unification of weights and measures by Qin Shi Huang, the very first emperor in ancient China, which took place in 221 BC. Since then, the official weights and measures have remained unified regardless of the changes in China's ruling dynasties. We observe two trends in the measurement development in ancient China. One is the constant pursuit of more uniform and accurate measurements. Take the lens measurement as an example. In the earliest time, people used body parts as measuring tools. For example, they used to measure a chi by handspan, in which chi is a Chinese measurement unit similar to food. After that, people used natural objects as measuring instruments. For example, they aligned and counted a specific number of grains of millet to define one chi. This mirrored the modern metrological approach. Later, people made artifacts as measurement standards. The picture here shows the ancient Chinese Huangzhong pitch pipe, which served not only as lens standards, but also as acoustic standards. This embodies the intrinsic link between length and frequency, which is what we know well in the modern metrology. Measurement vessels for capacity and weight also underwent evolution from everyday household items to the measurement standards. The second trend in ancient Chinese measurement was the constant pursuit of more authoritative, convenient, and precision measurement. First, take the ruler as an example. The material was constantly upgraded from bone to jet to ivory, and it has a wide range of uses. The second, there emerged the multifunctional measuring instruments. The very representative of this kind was the Xinmang bronze caliper of 9 AD, which share a similar shape with the modern vernier calipers, and also has a fixed ruler and a movable ruler, which can easily measure the depth, diameter, and the thickness of an object. The third, there emerged all-in-one measurement standards, a prime example being the Xinmang Jialiang of 9 AD, which integrated 5 distinct volumetric standards into a single artifact. Another famous example is the compass, which we know is one of the 4 great inventions of the ancient China. It's used for indicating the direction of the Earth's magnetic field. The compass played a great role in the development of the maritime navigation. In 1977, China officially signed the Metre Convention, and the NIM joined the global metrology community. So I would like to talk about a few of the outstanding contributions of China and NIM in particular to modern metrology, as well as our efforts to address global challenges. The first is time and frequency. In 2014, NIM started to submit data of NIM5 primary frequency standard to the BIPM and participated in the calibration of TAI. Since 1980, NIM and the NTIC has been participating in the International Atomic Time Corporation. By February 2025, the total weight of the atomic clock operated by NIM and NTIC in TAI calculations was 24.2%. There are several other Chinese institutes make contribution for TAI. By close collaboration with NIST of the US, NIM measured the Boltzmann constants by 2 independent methods, the Johnson noise thermometry and the acoustic gas thermometry. Both of the results were adopted in the final adjustment of core data, contributing to the redefinition of the Kelvin. In 1980 and the 90s, NIM made contribution to the determination of electrical constant RK and RJ. Since 1990s, NIM has finished the atomic weight measurement of 10 elements, which were all accepted by the IUPAC as the new standard values and evaluated to be the best measurement. Next, I will briefly talk about our efforts to address major global challenges. The first is climate change and environment. NIM has close collaboration with NIST and NPL in this area. Established China's first urban-scale carbon emission monitoring and inversion system in Zhengzhou, a megacity in central China, which can obtain an accurate and responsive high spatial temporal CO2 inventory. The second is health and life science. During the COVID-19 pandemic, under the CCQM framework, NIM jointly coordinated 2 international comparisons on nucleic acid measurement of the SARS-CoV-2 with LGC and the NIBSC of UK and the NIST of the United States. Concurrently, in collaboration with BIPM and the NRC of Canada, NIM led international comparison on monoclonal antibodies of SARS-CoV-2. So NIM has developed the reference material supplied to more than 1,000 institutions in China and 20 countries worldwide. In conducting basic research and addressing major challenges, we have come to recognize that metrology work operates in 3 dimensions. Beyond basic metrology and legal metrology, it must also serve the need of various industries such as energy measurement, marine measurement, communication measurement, environmental measurement, etc. I believe these industrial applications represent the potential areas for metrologists to invest in their expertise. This is where the applied value of metrology truly manifests. Finally, I'd like to conclude with 3 points. Since ancient times, China has been fully aware of need to unify weights and measures, and has continuously pursued the improvement of measuring instruments and means. Engagement in the global metrology community fosters the advancement of Chinese national measurement capabilities and contributes to the progress of measurement science. The last point, metrology drives advancements in science and industry, economy, and trade. So we need to work hard. Thank you for your attention. That's my presentation.
Thank you, Dr. Duran, for this very comprehensive talk. I hope you will be able to stay with us.
Yeah, sure.
Okay. For the questions. Okay. I now call Dr. Martin Milton, if you wish to join us. Dr. Milton, I think, is the director of BIPM. I think that everybody now knows what is BIPM. He has been a director since 2013, after working at a national physics laboratory from 1981 to 2012. He's chairman of the Joint Committee of the Regional Metrology Organization and the BIPM, and the Joint Committee for Guides on Metrology. Honorary professor in the Department of Chemistry at the University of York, fellows of several institutions. And, we are very glad that you can present us 150 years of BIPM in 15 pictures. This is the title of your talk. Thank you.
Thank you, Professor Casserly. Excellencies, distinguished guests, ladies and gentlemen, colleagues. I gave myself this title, celebrating 150 years in 15 pictures. It's actually in 15 minutes, and you'll quickly work out that that's a compression ratio of well over 1,000,000 to 1. So you'll understand that not everything is included. But I'd like to even make life more difficult for myself by stepping back again to the time before the BIPM was established, because I want to talk a little bit about the origin of this phrase we keep hearing, pour tous les temps, pour tous les peuples. Where did it come from? Well, I think we've seen earlier that it appeared on this medal dated 1837. But what is this medal of 1837? I step back quickly. So in 1791, the National Assembly here in France agreed on the definitions of the metre and the kilogram, and they launched those expeditions to carry out the work. Delambre and Méchant, and Lavoisier was commissioned to create the first standard of the kilogram. But in that first regulation of the National Assembly, they stated that the Preferred artifacts would be presented back to the National Assembly, and when they were recognized, a medal would be printed, and that medal would be printed bearing the words "À tous les temps, à tous les peuples." Well, the artifacts were presented in 1799. We heard a little about the story, but you know the medal never got printed. But things got worse in France, because in 1812, France abandoned the exclusive use of the metric system. Napoleon, the emperor, of course, seeking greater support, very concerned about his military plans at the time, agreed a number of compromises with the countries of the whole, and one of them is that they would allow non-decimal usages within the measurement system. They would allow 1/3 of a meter to be a foot, for example. Now, Laplace, the great mathematician, had written the year before that the principal advantage of the metric system is in its decimal division. So there in 1812, the decimal division advantage of the metric system was diluted. But in 1837, France again agreed to the exclusive use of the metric system. This medal was printed thanks to a benefactor in Lyon who funded its production, and there it has the great phrase, "For all times, for all people." The text at the bottom, I expand there to mark the exclusive usage of the decimal measures in France on the 4th of July, 1837. And of course, on the back was the picture of this celestial description of the quadrant of the Earth. But much more was to happen in the 19th century, of course, to the metric system. The first thing I would identify is that confusion developed as to which were the true standards of the meter. Were they truly the artifacts deposited in the archives in 1799? Or was it truly 1/10 millionth of the quadrant of the Earth going through the Paris Observatory? Or was it actually traceable to the toise? This is the surveying unit, about this much, about 2 meters, that was used in the big surveying work? Or was it one of the other intermediate meter standards held in many other institutes in France who were working with the system? So there was that confusion, but there was also more demands for accurate measurements. This is the period where European nations were very concerned with the importance of mapping, in part because one wants to know how much land one owns, in part because one wants to know how far the artillery will fire, but then discovering that the maps of one nation don't agree with the maps of another nation at the border. Part of this was possibly allocated to a discrepancy in the meter. This period is the period of the coming together of the industrializing nations in the great exhibitions. Firstly in 1851 in London, and then subsequently in Paris. I have a picture here of the great exhibition in 1867 in Paris. That's not the Eiffel Tower, by the way, but the exhibition center you see is this concentric building in the distance there. And right in the middle is a pavilion, almost like a temple. And this thing right in the middle of the exhibition, this is the Pavillon des Poids et Mesures et Monnaie. These are the most important things when the industrial nations come together. It's weights and measures, well, and money. So they had a commission that was going to award prizes to the best performing equipment in different categories. That commission did its work, and at the end it wrote a report that was submitted to the French government in which they stated it was difficult to do this kind of work because the measurement standards in different countries were such that they couldn't compare equipment to the standards that would have been necessary. So the report was given to the French government, and on the 16th of November, 1869, Emperor Napoleon III invited states to send representatives to Paris to form the International Meter Commission, the international gathering that would work towards what we now know as the Metre Convention. At that time, 25 states participated in that work. Now, the work of the Metre Commission was of enormous interest in France. I can justify that statement by saying that the president of France himself was personally concerned. Here's a cartoon from the press in 1872. We see President Adolphe Thiers here. He was not a tall man, but we see him standing next to something. Perhaps that's a toise of 2 meters, but I think what the cartoon really shows is that these people here are really over 3 meters tall. Anyway, that was a cartoon, but we also know from other pictures of the work to form the metals, to form the alloys, to create the first prototypes, that Thiers himself was present at those events. He's shown in a number of pictures that were published at the time. We also know that the work of the Metre Commission was considered to be of enormous importance by the French government, because they chose to mark the event by commissioning the production of 55 vases from the Manufacture Nationale in Sèvres. 55 vases with 55 names on of the participants in that commission. We are very fortunate at the BIPM that we have one, the Péligeot vase, which was given to us. Of course, BIPM didn't exist when the vases were produced. And those vases are spread around the world, a very few in measurement institutes, a large number in museums and in private holdings. Well, this is another special year for the BIPM and for the metric system, the SI. So we've had a project this year, also with the Manufacture Nationale in Sèvres, who are, of course, our neighbor, to produce a new edition of vases, a new edition of 17 vases that we're making available to NMIs who wish to buy them. Here's a picture of them. I say 10 have been answered for already, but there's still an opportunity for 7 NMIs to be the owner of a 150th anniversary vase of the Metre Convention. There they are, and they're very beautiful. Anyway, the Metre Commission proposed the signing of a Metre Convention, which took place on the 20th of May, 1875. By the way, we know from the records of the signing of the diplomatic papers that the signing took place in the afternoon. We know it took place in the session after lunch. So I'm going to claim that the signing of the Metre Convention took place 150 years ago during the time of this talk. There were 17 nations, each signing 17 pieces of paper, so perhaps it took a long time. Anyway, when we had the 100th anniversary in 1975, we had an event in the Salle d'Horloge, and I show this picture here. I think it's a rather nice picture taken on that event, on that occasion. It might look like a picture of a rather large display of flowers. But if you look below the flowers, just here, you can just see there is the Metre Convention in a big frame, but it was available for everybody to see at that event. So 17 states signed the Metre Convention, and they signed a document that started with the words, "The high contracting parties desiring the international unification and perfection of the metric system." That is the true and formal name of the Metre Convention. The term Metre Convention doesn't appear anywhere in the text, and most nations use this wording in their formal acts to adopt the Metre Convention. But we'll carry on calling it the Metre Convention. So the French government committed to give to the BIPM, the organization founded by the signature of the Metre Convention, a site, and that site, of course, is the Pavillon de Breteuil, which itself has a history going back well before we took it over in 1875. I want to talk now about the most eminent of the 12 directors of the BIPM, which is Charles Edward Guillaume. Charles-Edward Guillaume was Swiss, born in Fleurier in 1861. He worked at the BIPM for 53 years. They didn't have retirement like we think about it now. And in that time, he was director for 21 years, including much of the First War. He wrote in 1902 a statement which I think captures the scope of much of his work. Often in the last centuries, geodesy has preceded metrology proper, or at least dictated its progress. He knew that the top priority for the new organization, the BIPM, was the meter. It was the meter that was needed by geodesy. It was geodesists who, in most part, had come together in that meter commission to form the BIPM. And his work was concerned very largely with the meter. You see a photograph of him, You see a photograph of him here in the courtyard, working with two assistants, and on the reels he has big surveying wires. Now, he became famous and won a Nobel Prize in 1920 for the discovery of INVAR, because the expansion of these surveying wires used for the set surveying bases was a critical source of uncertainty. He discovered that the alloy of 64% iron and 36% nickel had greatly reduced thermal expansion. He received a Nobel Prize in 1920, and there's the citation, in recognition of the service he has rendered to precision measurements in physics by his discovery of anomalies in nickel-steel alloys. I love this picture we found in the archives of an object that seems to have been created by cutting pieces of cardboard to show the phase diagram of iron-nickel with manganese in the other direction. This apparently was prepared for his Nobel Prize discourse in Stockholm. I guess he took photographs of it rather than taking that itself to Stockholm. Anyway, his certificate has on it, of course, the Pavillon de Breteuil, the only Nobel Prize certificate with that on it. So Charles-Edward Guillaume was extremely well connected in scientific circles in Paris. He was a long-standing and close friend of Pierre Curie, and through his links with Pierre Curie, of course, became very friendly with Marie Curie. Marie Curie had a part-time job teaching. A teaching job brought her to Sèvres. So we can see the linkage that brought the Curies often to the BIPM. For example, in this picture, we have Guillaume on the left and the Curies on the right. Marie Curie would eventually leave her standard of radium with us at the BIPM, and we have logbooks with her signature and the signatures of other distinguished Nobel Prize winners at the time, registering that radium standard with us. Guillaume was also involved in the very difficult process of advocating for Marie Curie to become a member of the Académie des Sciences in Paris. He was one of the prime supporters of her candidacy to receive that position. Guillaume was also a friend of Gustave Eiffel, who of course built the Eiffel Tower in 1889. Here's another cartoon. A cartoon, this is Charles-Edward Guillaume. I know it looks a bit like Einstein, but that's Charles-Edward Guillaume. And he's holding here an INVAR wire because he was involved in a public experiment, if you like, to celebrate the power of the sun in 1912, where he laid out 116 meters of his INVAR wire down from the top of the Eiffel Tower, down from the second stage of the Eiffel Tower. And as the sun moved from behind, or as the clouds moved across the sun and exposed the sun, we read the Eiffel Tower expanded, and this apparatus that he placed 2/3 of the way up the Eiffel Tower, that the needle started to move, showing the expansion of the Eiffel Tower in response to the sun. I have to say that if one calculates very quickly, the expansion of the Eiffel Tower with respect to a degree of temperature change isn't very much. It's around 1 millimeter. So this actually was a very difficult experiment. But let's say he made the point for the wider community about the power of the sun. Now, in order to celebrate our 150th, one of my colleagues, Celine Fellag, has done an enormous amount of work with the BIPM archives. In the BIPM archives, she's found some photographs that we'd never seen before. Many of these are assembled in her book, which we're going to launch tomorrow down in Versailles. But let me show you a couple of highlights from the archives. Perhaps the biggest highlight, Celine found some small photographs, black and white photographs, and on the back written the name Robert Doisneau. Robert Doisneau, of course, a very famous French photographer. We had no idea he had been to the BIPM. Celine contacted the Doisneau archive, which of course is meticulously maintained, and they identified around 14 photographs that we could say were of the BIPM. Here's one of those contact sheets. You can see scientists in the labs, all observing something, see the common theme here. And then top right, we have what is a classic picture of the prototype kilogram, very beautifully taken one there with the slight shadow effect that he's chosen to use. So in order to celebrate our 150th, we wanted to update that legacy by commissioning a current photographer to take photographs of the BIPM today to mirror the photographs by Doisneau. I show you just 3 here that illustrate the new work of the BIPM. So we have a photograph here from the ionizing radiation department, which we started in 1964, who do the work that provide the standards for national measurement institutes to underpin radiation therapies, X-ray doses, and standards for radioactivity. In the time department, activity that we started in 1984, where we now maintain the UTC, the Universal Time Scale, in collaboration with 85 laboratories submitting data each month. And in the chemistry department, work that we established in 2003 to provide standards for pure substances used by metrology institutes around the world for measurements of food and pharmaceuticals and to support laboratory medicine. I'll move on quickly from the meter, because we've had some good discussion about the meter already. But say in 1960, a huge change in the presentation of the work of the BIPM with the decision to use the name International System, SI, Système International, for the system of units that they had at that time. In 1960, it was only a 6-unit system. But shortly after, in 1971, it was agreed that the system would encompass a 7th unit from the chemistry community, the mole, to allow the application of the SI to measurements in chemistry. Now we have a 7-unit system linked to 7 fundamental constants. Our new system since 2018, a system that allows for the use of quantum mechanisms to realize accurate standards. And right at the center of those measurements is the Kibble balance we heard a little bit about earlier. We have a Kibble balance at the BIPM, and here's a picture of that enormously difficult and enormously important experiment that goes on at BIPM and in a number of other NMIs around the world. The agreement of the adoption of the SI based on fundamental constants was taken at a meeting of the General Conference of 2018. I have to say, if I have to pick 15 pictures about the BIPM, this has to be one, because this is that moment that those who were there will remember of that spontaneous joy and excitement and satisfaction that the work of decades had been achieved, and it had been achieved by unanimity despite real technical difficulties that we'd worked through together. So that's a very happy picture of the community. So as I finish, where next? Where next for the CIPM? Where next for the BIPM? Well, the vision for the metric system was ambitious. Pour tous les temps, pour tous les peuples. For all times, for all people. We should certainly have the same ambition for the SI. I'm sure we do with our new fundamental constant-based SI. And we should have the ambition that it's continued to be underpinned by the latest science and support the latest needs. But I'd add to that that the vision for the Metre Convention is also ambitious. I go back to that opening phrase of the text of the convention, desiring the international unification and perfection of the metric system. Currently, we're an organization of 64 member states and 37 associates. We've had discussion this morning, but I believe that the future should be that we recapture that ambition, that the work of the metric system, of the SI, of the BIPM, of the metrology community should be universal and should visibly involve all states in the world. So there is a huge challenge for us all, one that I believe is worthwhile and one that I believe we have a lot of support for. Thank you very much.
Thank you, Dr. Milton, for a very inspiring talk. I'm afraid that we are running a little bit late. I don't know if we have time for a few questions. Ask the organizers. Okay, since there is no, I will take maybe 2 questions. I would like to ask first a question to Dr. Duan, because I realize that an aspect that is often forgotten of the metric system is decimal division. I wondered when this decimal division of the system was adopted in China. If you can tell us that in a few words.
I'm not sure, but from my knowledge, in the ancient time, we use how to say a double, not double. It's a dozen, a 12 system, and 10. How to say that? It's a decision. Decimal. Okay. So I think many is confused. You know, some in the ancient Chinese system, we have the decimal system. We have the 12 system. So I think I need to check. One is the first time the decimal come to our society. I cannot give you exactly the date about this now.
Thank you. I think, Ken, you have something to add to this?
Yeah, is that on? Yeah. Actually, the commission that created the metric system considered going with non-decimal systems initially. Each of the components that we think of the metric system was debated and argued about, and there was a very serious consideration of going with base 12. At one point, the very eminent mathematician Lagrangians, you know, you've heard of Lagrangians, proposed in true mathematician style that it should be base 11 because it was a prime number. I could never figure out if he was joking or not, but it was a serious, I mean, he put it out there, but yeah, the idea was ease of calculation, but each of these was added, each element was considered separately. The thing we're looking at is a piece of work. It's not a natural thing. It requires work and constant maintenance.
Okay, I see that the timer is flashing red. If there is one question from the audience, I don't know, yes,
Bill always has a question.
I think that did everybody hear? It was about the 25.
It's about the 25 and the 17. Well,
25 were in the commission. Only 17 signed. What happened to those other 8 people or 8 nations?
So there was some discussion in the Metre Commission, not only about units, but also about money, that other central thing in the exhibition. And the discussion broke down to a group of nations who were very committed that there should be a permanent repository and a permanent body looking after the standards. Those won the day. And a small group of nations who didn't want to sign up to ongoing costs. Now, I can say one of those was Great Britain. There were others I won't mention. So the thing became a little bit split over ongoing costs, but I have to say the fact that we're still here after 150 years, the majority who chose the model that subsisted got the answer right. However, very shortly after 1875, 3 of those who didn't sign came on board, particularly the Netherlands and Great Britain.
Thank you. I think we have to stop here. I would like to thank the 3 speakers of this session. Thank you very much for these talks and the questions and the answers. Thank you.
Right, so thank you so much, Dr. Casoli, Professor Alder, Dr. Yuan, Dr. Milton, for those absolutely fascinating talks about the history of the metric system. It literally took us around the world and through so many eras. So we've heard from metrology past, a bit of metrology present. It's time now to look into the mists that are currently hurtling towards us. So j'ai le plaisir de vous...
And I have the pleasure to introduce the moderator of our last session on the future challenges of the world metrology.
Very honored to be moderating the final panel of this afternoon, which will be on the future challenges for global metrology. And we'll be looking at some of the tangles faced by NMIs around the world, some of the shared challenges from various branches of metrology, and how it is developing in regions around the world. But before we dive into that more deeply, we'll be hearing first from some of those on the front line of keeping metrology agile and able to give mankind a boost over our collective hurdles. Please take a moment to have a look.
Measurement forms the backbones of everything. Whether it's tracking carbon emissions or ensuring the safety of newly discovered medicines, reliable measurements enable us to make effective decisions. What makes metrology so powerful is its precise and universal nature. When measurement standards are agreed upon globally, they help ensure consistency and equities across borders.
The evolution of measurement standards and measurement instruments allows metrologists and scientists around the world to achieve accurate results, obtaining smaller uncertainties every time, and therefore providing a base for decision makers in which to implement policies that aim for the solution of global challenges.
As the transition to renewable and decentralized power generation accelerates, metrology will ensure that every watt generated, stored, transmitted, and used is trustworthy. Electrical grids rely on precise data to balance demand, manage load shedding, and integrate renewable power into the grid. Without accurate measurements, the electrical grids cannot function reliably. After all, you wouldn't want your solar panel thinking it's nighttime at noon.
In the medical field, precision can be a matter of life and death.
from calibrating diagnostic equipment to developing new transmit methods. Metrology underpins medical research and practice. High-precision measurements in blood analysis, genetic testing, and drug formulation contribute to more effective, safer, and more accessible healthcare solutions, addressing the development to personalized medicine.
To improve quality of life globally, we must transform healthcare, agriculture, food and water safety, clean energy, and manufacturing. AI is driving this change, but it needs a strong foundation. That foundation is metrology, the science of measurement. Without metrological traceability, AI results can be biased or unreliable. Metrological standards ensure AI delivers precise and trusted outcomes. As the world embraces digital transformation, metrology is the unseen force making AI not just smart, but reliable and fair. Metrology-driven AI is the way forward to build a predictive, sustainable, and trustworthy future.
A huge thank you to all of the contributors to that video that I think really sets out the stakes of metrology and how it touches on so much upon which our futures rely, and has been made clear by many of the conversations we already had. Time, tide, and any healthy scientific field waits for no man. Now, biologists and chemists used to be left pretty much to their own devices when it comes to metrology. And since they were brought into the fold, our next speaker says that metrology actually has its work cut out to keep up with biology and chemistry and advancements in those fields. So it's my great pleasure to invite Professor Willie May up to tell us more. Professor.
Good afternoon. I said that, I don't remember all that. I have stepped away from this community for about 6 or 7 years. I miss you guys. I'm so happy to be invited back. See if I can. You know how. I can't guarantee this is going to work, but there we go. Okay, cool. Okay, gotcha. So we all know why we're here, so that we don't have to spend a lot of time here. We're here to celebrate the Metre Convention, 150 years old today. And as has been said earlier, this all started with the establishment of the International Committee on Weights and Measures. At that time, 18 wise men, now 18 wise people from around the world, who were elected to oversee the meter system, or the measurements worldwide. Now, these 18 wise people can't be all-knowing, so there are 10 consultative committees that they've set up to provide deeper expertise in various measurement areas. And the one that covers chemistry and biology is the CCQM, or Consultative Committee on Metrology and Chemistry and Biology. I think the initial title was the Consultative Committee on the Amount of Material, but really, when you're talking about biology, it's not only the amount, it's a bit more, and I'll say more about that later. Now, the context for chemical measurements. For metrology, and obviously chemistry is core important to virtually everything about life, and all in industrial sectors and technology areas. For metrology and chemistry, how do we set that apart from physical metrology? For metrology and chemistry, you're talking about the measurement, a determination of a specific quantity, a specific chemical entity in a matrix. So it's not the amount of substance, it's the amount of a particular chemical substance in a particular matrix. So it requires not only the amount, but the particular identity of that entity that we are determining the amount of. So, and chemical measurements are multidimensional. It's not just the amount of stuff, it is the amount of maybe 10 to the 5 different chemical entities across a broad range of matrices, from food, soil, blood, you name it, and in mass fractions covering over 12 orders of magnitude. And we're talking about measurements that are made on a daily basis. If you go to the extreme, probably you could extend that another 2 or 3 orders of magnitude. So that's the complexity of measurements in chemistry. Large number of compounds measured, large range, mass fraction range, and they can be in lots of different types of stuff. This just gives you a bird's eye view of the complexity when it comes to measuring chemical entities in foods alone. So in foods, 50 to 60 elemental species measured every day, more than 10 to the 5 organic compounds or species, and they cover a broad concentration range. So that's the scope of the problem that we're trying to address, that we have to address. I often put this slide up to dig at my physical metrology friends, so here it is again, guys. The questions that you ask in physical, chemical, and biological measurements are different. A physical measurement is basically, what is the mass of Willie? 85 kilograms. What is Willie's blood pressure? A chemical problem is, how much cholesterol is there in Willie's blood? A biological problem would be, which cholesterol-lowering drug would be best for me in terms of efficacy, lowering my blood pressure, and the absence of side effects. So the questions that you ask as you go from physical metrology to chemical and biometrology, they explode in terms of dimensionality and complexity. So the CCQM was given the task to try to address this basically impossible problem. So the first meeting of the organization tried to make it as much like physics as we could. So we thought about doing things like study of metals in solution, measurement of gases. Now we could have done this, and we could have done this well, but it would have had no impact on society. So I'm getting a little ahead of myself. We decided for metrology and chemistry and biology, it had to have an impact on society, not just a bunch of NMIs getting together and doing comparisons and putting those in a database. We wanted it to address human and societal problems at the same time. So after 2 meetings, we agreed on some terms of reference, and we were off and running. So the terms of reference for the CCQM is or will be responsible for developing, improving, and documenting the equivalence of national standards, those who are certified reference materials, reference measurement procedures, reference methods for chemistry and biology. It also advises the CIPM on matters related to chemical and biological measurements, including advice on the scope of the BIPM's scientific programs in chemistry and biology. So that is the task that we gave ourselves. So I think I've said that. You can see that from those meetings of about 10 people, mainly men, in 1991. Now the CCQM has gone to a large organization, 43 institutes attend meetings here in Paris at the BIPM every April. There are 12 working groups and six special task groups within the CCQM. The annual meetings that are held in April are attended by representatives from around 110 representatives from member and observer states, and including people online, almost 600 that are there during CCQM here in Paris on an annual basis. And yes, we have for those you from the metrology community, this means something to you. Over 6,400 CMCs are currently published in the key comparison database based on work that we've done. This is the second from the last meeting I attended. I probably should have gotten a more contemporary picture, but you can see the group is a bit more diverse than it was when it started back, say, more than 25 years ago, and it has expanded to include the global society, and it expanded a lot more since I've gone. So, looking to the future, we are now, or they are now, having comparisons that respond to grand challenges. And you can see the areas that we're doing comparisons in: climate change and the environment, health and life sciences, food safety and nutrition, energy, advanced manufacturing, digital transformation, semiconductor characterization. So actually having comparisons to go into the BIPM database to look, but also that address, again, global and societal problems. And I think the fact that we're focusing on these things that actually address human issues and so forth, that is the reason for the rapid and explosive growth of interest in this area. Don't have time to go into this, but we have several types of comparisons that we've developed and to guide our work. This is just examples of a few of the several hundred comparisons that we've conducted over the last 25 years. Just example of some having to do with clinical chemistry. And we've done two things. One thing is to actually do comparisons to assemble or accumulate data to put in the BIPM key comparison database. But we felt that we had an obligation that went a bit further than that. So we actually do comparisons on the reference materials that NMIs sell to their customers. And that is what you see there in the lower CCQM Key 80, where we've compared the veracity, if you will, of reference materials issued by NMIs for the same quantity. In this case, this is creatinine and serum. So this actually shows customers how well the comparison of the reference materials that we provide. So when, for example, NIST doesn't have reference materials, when they run out of stock, they know how reliable the reference materials that they might get from another NMI might be. And this is valuable information that we provide to our customers as a service to them. Just an example of some of the things we've done. So for the Chem Bio community, the CIPM MRA has provided a means for NMIs to document and vet the capabilities they maintain to underpin the measurement services that they provide for customers. That is what is done in physical metrology as well. The one thing in addition that we're doing in the CCQM, I have done, is provide a basis for customers to assess the degree of comparability of a given service. That is the reference materials provided by NMIs as well. So the CCQM has really become a global forum for progressing the state of the art for chemical and biological measurements. The CCQM has, without a doubt, enabled NMIs to identify spikes of excellence within the Chem Bio world that have led to the establishment of strategic collaborations for both research and standards development purposes among NMIs. So through our exercise, we are able to identify potential partners in delivering measurement services. But what that has done for the community is improve the quality of chemical and biological measurements within the worldwide NMI community, which has led to better, more, and higher quality services to end users. So again, it's not just something we get together as a club and carry out comparisons to put it in the key comparison database. We are actually reaching out and providing superior services to the worldwide community of end users. Thank you for your attention.
Please do take a seat because we need your witnessing of the shaping of the conversation to come. So before we dive into the promised panel, we will continue to create these bridges between metrology's past and its contemporary importance. Our next speaker will be exploring how it plays such an important role in limiting or letting loose our capacity for technological and social progress. It's my great pleasure to invite Dr. Natalie von Siemens to take the stage.
Standards, international, technology, efficiency, quality, scale, production, disruption, better life. Ladies and gentlemen, may I present the Industrial Revolution, The biggest impact on human life since the Neolithic revolution and the development of agriculture about 20,000 years ago. It was probably not conceivable without the principle of the French Revolution, liberté, égalité, fraternité, and it was certainly not possible without the young science of metrology. The science which is a prerequisite for precision, scalability, and global technical progress. Standardization and interchangeability. Industrial production demanded exactly the same parts. Metrology made it possible to standardize measures so that components matched regardless of the place of production. Efficiency in mass production. Precise measurement enabled efficient adjustment of machinery and serial production, a core characteristic of the Industrial Revolution. Quality control. Metrology made it possible to check products for their dimensions and tolerances. Defective products could be easily identified and non-conformity could be reduced. International trade relations. Standardized weights and measures facilitated trade. The introduction of metric systems and international standards supported the global spread of industrial products. The Metre Convention that we celebrate today. And scientific progress as such. Many developments of the Industrial Revolution, for example in thermodynamics and mechanics, were based on precise measurements. Metrology is doubtless the basic science of the Industrial Revolution. And I am convinced metrology is also key for the digital revolution. But first, back to industrialization. There are few places in the world where it is clearer than in Paris, there is no revolution without revolutionaries. Today, I would like to remember two of my favorite revolutionaries. My great-great-grandfather Werner von Siemens and my great-great-grandfather Hermann von Helmholtz. They were close friends, their children married, and 5 generations later, I have the honor to be standing here. Werner von Siemens, the great entrepreneur who discovered and applied the dynamoelectric principle, which is fundamental to industrial production as we know it today. Hermann von Helmholtz, the physician, the scientist and philosopher, who not only left us the eye mirror, but also contributed significantly to the recognition of the then still controversial law of energy conservation. Both relied on the still young scientific mathematical method. Together, they founded the Physikalisch-Technische Reichsanstalt, now known to probably all of you as PTB, a revolutionary institute. It was the first German public-private partnership for science, the first for scientific research outside universities, and the first to combine basic research and industrial application, as well as a physics and a technology department. It is no surprise that the revolutionary setup later created breakthrough measurements in science, leading, for example, to quantum technology based on Max Planck's theory. There's another pattern first embodied in the PTB, a pattern that we again recognize in the digital revolution. Silos are being torn down and cross-disciplinary structures are being created for innovation and horizontal dialogue. But back to Werner von Siemens and Hermann von Helmholtz. Both wanted to use the tremendous possibilities of the new age to create benefits and serve mankind, to be able to execute projects of previously unheard scope and scale, like the famous Indo-European telegraph line. Werner von Siemens knew to cover the distance from London to Calcutta with a telegraph line, he needed plug-and-play cables. He also needed reliable and accepted standards and the definition of electrical measures. These were on his wish list for the first task of PTB. The result? A message from London to Calcutta no longer took 30 days, if the messengers survived, but 30 minutes, reliably. At the beginning of all such great changes are people. There is no change without change makers. Change is difficult and complex and very often not welcome. Change makers need encouragement and appreciation. We all need encouragement and appreciation. This is the purpose of the Helmholtz Award and the Werner von Siemens Ring. The Helmholtz Award for outstanding work in the field of precision measurement in physics, chemistry, and medicine is awarded every 2 years in 2 categories: basic research in metrology and applied metrology. In each category, the prize consists of a certificate and prize money of 20,000 euro. In 2024, both categories were awarded for pioneering successes with light. With the newly developed microscopy technique, the physics group, led by Professor Baum from the University of Constance, succeeded in capturing the extremely fast movements of atoms and electrons like a movie. For applied measurement technology, the award went to the interdisciplinary physics and medicine team from Leibniz University Hannover, Professor Bernhard Roth, and the University Medical Center Rostock, Professor Steffen Emmert, for their innovations in optical biopsy in skin cancer diagnostics. The Werner von Siemens Ring is regarded as the Nobel Prize in Technical Sciences and is endowed with 100,000 euros. The 42nd Werner von Siemens Ring honors Peter Kürz from Zeiss and Michael Kösters from Trumpf for the development of high-NA EUV lithography and the industrial utilization of EUV technology, the core of high-performance microchips. Which brings us to the heart of the digital revolution. And again, it's about standards, mechanization, international production, scale, disruption, technology, and better life. And again, metrology is key for revolutionaries. Because precision metrology enables us to work at the nano level, as in the case of Peter and Michael. And again, we need a common metric, because it leads to standardization, and standardization is the key to conquering new markets. Standards increase the receptiveness of existing markets to new products. Standards offer investment security and boost the acceptance of innovation. And examples from Siemens AG. The market for innovative equipment for digitalization in the smart grid sector only really got opening after the IEC 61850 series of standards. The same applies to cybersecurity solutions for SCADA solutions and OT systems. Here, it was the IEC 61443 that enabled the business breakthrough. Now, imagine machine learning and generative agent AI and stop. In all the breathlessness chasing great entrepreneurial opportunities, it is important to pause for thought. Because in every revolution, good outcomes come at a price. With the Industrial Revolution, we first encountered a form of poverty that we call pauperism. With the Industrial Revolution, the overexploitation of our planet began. Today, the climate crisis and its causes can no longer be denied. And many fear the digital revolution. Jobs not being necessary anymore, digital divide, geopolitical tensions, and war. The complexity of the reality we experience is increasing ever rapidly, not least due to artificial intelligence. I am convinced that the digital revolution is still young and that it holds the opportunity for a better life for all people. If we embrace complexity and take the hard way of data-driven scientific knowledge, just take climate crisis. In the future, smart cities will be essentially sensor networks enabling not only efficient energy supply from renewables, but optimized and timely health services or intelligent mobility. Hermann von Helmholtz wrote in 1891, "Science and art are currently the only remaining bond of peace among nations. Their ever-increasing development is a common goal of all, to be pursued in the common work of all, for the common benefit of all. This planet and all its inhabitants have the brightest future if we remain in dialogue, in education and in science, in culture and politics, technology and entrepreneurship." Like all the people who have been working for the Metre Convention for 150 years, a very diverse team working together for all people and all times. Happy birthday. Thank you for the energy that you commit to this great cause. It's worth it. And scientists know energy is not lost.
Well, that's raised the stakes somewhat. I'm hoping that our next panel will keep the energy up. If I can invite all of the panelists to please join me on stage and take any seat that takes your fancy, and then we'll crack on with the conversation. Thank you so much, Dr. von Siemens, for your really moving speech there, which I think has really set out the stakes of metrology beyond just the technical. So it is my pleasure to be joined by a very esteemed selection of experts who spent years crafting the metrological landscape. So yes, there we go. So before I crack on, I'm just going to whiz through and introduce the new additions to the stage. Bear with me 1 minute. So thank you very much, Dr. von Siemens, who we've heard from. Obviously, Professor Willie May, thank you very much. We are also joined by Professor Venugopal Achanta, Dr. Pascal Defresne, and Dr. Henry Rotich. So I'm going to start off with you, Pascal, because we've heard from Willie about the work being done in biology and chemistry. Dr. von Siemens has kind of widened the conversation beyond just the technical. But another really important field within metrology is time and frequency, which is your speciality. So give us a bit of a sense, first of all, what your field's priorities are, what you're most excited about, and what you wish could work a bit better.
Thank you for the introduction, and thank you to the BIPM for inviting me to share my passion about time and frequency. So the first priority that we have, it's not new, but it has to continue in the future, is to build UTC, the Universal Time Coordinated, which is the official time in the world, the reference in the world. So more and more in the world, we need synchronization of different systems. And to ensure this synchronization, we need a reference, and that is UTC. I can give as an example the telecommunication systems who need synchronization, certainly at the microsecond level, now financial transaction as well. So all these systems, the GNSS, the satellite navigation systems, also need very, very accurate synchronization. And so it is very important that the time and frequency community continues this continuous effort, because we have, it's not just one measurement. The time, we have to build it every day, every minute, every second. It's a global collaboration of time laboratories which are distributed in more than 70 countries. And so they are developed countries or less developed countries, and we have really a huge community which is collaborating on this global effort. So that is certainly the first priority that we have. Now we have heard this morning during the talk of Bill Phillips that we are in progress for a redefinition of the second, because we have now optical clocks with systematic uncertainties which are up to 2 orders of magnitude better than the primary frequency standards that are based on the current definition, so based on the cesium atom, one transition of the cesium atom. And so we need this new definition to allow frequency measurements with an accuracy that is at the same level as the technological developments that we have now and that will still evolve in the future. And so there is also another priority regarding the regain of interest concerning lunar exploration. The space agencies now ask us to define a reference time on the moon. Because due to the relativity, of course, the time on the moon is not the same as on the Earth. So we have to define a new reference for all activities on and around the moon, and to define theoretically what should be that time, and also how to realize it. Because at the beginning we have only clocks on the Earth. Maybe in the future there will be clocks on the moon, but for the moment we have only clocks on the Earth. So we have to propose some realization of that reference time on the moon. So that is maybe what is the most exciting for the moment, because we dream about the moon time.
I feel bad bringing us back down to earth, but thank you so much for that. That's super exciting, and it's great that we can, look at future challenges in a positive way, with a sense of excitement rather than just seeing them as challenges and hurdles. Dr. Rotic, I'm going to come to you now. We've heard throughout the day talk about just how much has been achieved by collaboration, how important it is with global collaboration. How does collaboration, what is it looking like in the African continent when it comes to collaboration? The continent's seen steady progress, because I think originally there were no African signatories. Today we have 6 full member states, 3 associate states. But when we spoke, you said you were super excited about the potential for all of that to pick up in light of some of the potential of the African Continental Free Trade Agreement. So tell us a bit about collaborative plans on that front.
Thank you very much. My name is Dr. Henry Rotich. I'm the current chairman of AfriMets and also the chairman of Pan-African Quality Infrastructure. I think that puts where metrology is one of the pillars in the PACI structures. The institutes, we are 4 of them. So metrology within the continent, of course, was a bit the latest entrant. We started with a few members who signed the Metre Convention, and we have grown over time. Right now, we have 5 full members and 7 associates. And within the Regional Metrology Organization, we have a number of countries who are members. And I can say that within the continent now, most countries are actively participating in some of the comparisons that we organize within the continent. Metrology is very, very important for us within the continent because we have the initiative of Africa Continental Free Trade Area. I'm sure you're aware that the continent is the continent with the youngest, the largest population of young people. And so there's a lot of innovation, a lot of development of new products which are required by these consumers who are young people. So we look forward towards metrology playing a very important role in value addition of the products that we produce, the raw materials that we produce, so that we also get value for what we manufacture and also what we produce as the raw materials. We can add value to these products. I know at the BIPM, I'm really happy because I've seen a lot of support from BIPM. From the very first time when we had the boots from BIPM stepping in Kenya, and I think Professor Willie came with a big delegation. That was in 2008, when we had the first metrology conference that we held in Kenya. And we've really benefited because we've had placement of our young scientists in most of the NMIs. We've also had support from NIST, Chris, even Tubitak Ume, and also other NMIs. I think when I'm here, every time I come for a meeting, one of the things that really surprises me is that I think we are true to the spirit of the Metre Convention to democratize measurements and also make it accessible to all. So when I look at the team today, it reminds me of the Chinese saying by Confucius, San Ren Xing, Yo Bi Wo Shi. It means for every 3 people walking, there must be one who is my teacher. So when we interact with the international community of experts at from NMIs, every time I engage, they're all willing to help. In fact, they don't say, wait, I write a letter. No, we deal with the issues right there and then. So I think we have reached that level, and we've really benefited as a region. And we look forward to more interactions so that we also develop metrology within the African continent. Thank you.
Before I move on, so that is the benefit that's been yielded by kind of external support given to African NMIs. What is the relationship between NMIs within the continent?
We have AfriMet, which is our regional metrology organization, which is linked to the BIPM as one of the regional metrology organizations. And we organize comparisons, which we have within the continent, and also we sometimes also have some comparisons that are coordinated by other NMIs, and we linked up with them. And this really helps.
Thank you so much, Dr. Henry Rotich. Dr. Gopal, now we were speaking about just how much has been coming out of India's economy. It's expanding rapidly. How's metrology keeping up?
Right. Thank you, Georgia. So our GDP is increasing, but we have a large denominator of huge population, right? So our challenges are to bring together or to meet the needs, to meet the expectations, and to meet the tradition. Just to explain, like, so our needs remain the same. Our needs remain the same, that like food and water safety and security. We need clean energy. We need to look at environment. We need to look at traditional medicine, for example. We need to look at traditional local industries. We need to look at the support, how we can give to the industry. And at the same time, we are also to be ambitious in the sense that, like, we don't want to be followers still. We want to be today, as far as newer technologies, whether it is quantum, AI, or digital metrology is concerned. We want to be in today's developments. So these are our challenges. Our challenges are to get all these things together and bring the focus of metrology to our policymakers, to our funding agencies, so that we bring in support and stand up and deliver for the nation.
How are those conversations going? Is there anything that the external community can do to advocate or to boost the impact of them?
It's always like, I mean, I come from a non-metrology background. I got welcomed very nicely by the community. So I say that, like, so metrology is a minority community in the world in terms of science and technology, but we need to be close-knit, and I see that cooperation is there. There is a lot of support. For example, PTB helps us, NPL UK, NIST. So we have close collaborations as much as possible. So PTB SARC program is one thing which is really helping the regional developments. Then we have PTB also part of Clean Ganga River project. It's a mission of Government of India. So we do collaborate with them as much as possible. So these bring in visibility needed for the metrology in the country. Yes.
Thank you so much. Willie, what do you think that the nature of the challenges of the CCQM are different to those faced by other consultative committees?
Well, yes, because chemistry is different. What we are doing is implementing the MR, the mutual recognition arrangement, in a way that makes sense and has meaning for the chemical community.
Please elaborate. So what meaning are you trying to build in that you think is currently lacking?
Well, first of all, the activities that we are undertaking really has meaning and provides growth opportunities for chemistry and biology and NMIs around the globe. If you roll the clock back 20 years ago, I would say that NPL had a chemistry program, NIST had a chemistry program, PTB had a chemistry program, and I'm sure I'm going to leave some folks out, but that was not very, very widespread. I think it's the work that we've done in the CCQM that demonstrated the benefit and impact of chemical metrology and chemical measurement science and metrology and biological measurement science to NMIs, to the countries, and that has led to an explosive growth of participation, but also it has driven hiring decisions in NMIs. Most NMIs now have an active chemical metrology program and biological program, metrology program. That was not the case 20 years ago.
That's super interesting. Natalie, when we were talking earlier, you were really emphasizing that you feel, and I think it was reflected in your talk, that the pathways and even the people that metrology needs to tackle whatever's coming down the road, they're already modeled in what came before. Can you tell us a bit more about that, please?
Yeah, thank you. I've chosen to bring with me both of my great-great-grandfathers because I think they symbolize a certain character trait which will be important in the future. So as much as we see a lot of differences from those times to today's challenges in the digital revolution, where we standardize in a different way. Look, this is done in open communities. It's about the standards and protocols that are arising there are rather club goods. So this is different. Still, I believe that there is a certain kind of person that we need to tackle all this. And the center of this personality I find in Werner von Siemens and in Hermann von Helmholtz is resilience. So resilience being the agility to change behavior or attitude vis-a-vis a challenge. That has a lot to do with purpose. So it's people with a purpose. So Werner von Siemens once said that the value of an idea lies in the use that it and the benefit that it generates for people. It's about embracing complexity. So Hermann von Helmholtz compared his work to mountaineering. And it was not that he wanted to enjoy the fantastic view once he reached the top of the mountain. It was to emphasize that sometimes you lose your way and then you have to turn back. So it's about being able to admit a mistake that does not make you a loser. So in that way, I think these qualities, they come together in people who have a mindset of problem solving and who can stay in dialogue. And I think that is what we need today, to to embrace the challenges that we face as opportunities.
Are you talking about that from the specific perspective of metrology's, the way that the metrological community looks at what kind of leaders it's trying to nurture, or is it a more general societal point?
It's both. It's both. You know, I don't think that it's a coincidence that the people I have been quoting were great revolutionaries in that time, and their horizontal basis was metrology. So if we learn from the past, then this is an example that we also would welcome today to keep up dialogue.
So you mentioned personal resilience, but particularly for our panelists coming from fast-growing regions, I'd open it to both of you. How important do you see NMIs as being to the current plan for resilience in either Asia or Africa? Henry, would you like to start off?
Thank you very much. I think, as I mentioned earlier, trade, the driver is the quality infrastructure. And metrology is right in the middle of quality infrastructure. It's a driver of businesses. So when you look at our emerging economies, we really need measurements, I think, more than ever. So investment in those areas is very, very important. And I think I'm also happy that the big NMIs are now also stepping in to support in terms of capacity building. For example, BIPM, there is the capacity and knowledge transfer, that initiative which has really trained a lot of, metrologists from developing countries. So I think there's a lot of initiative towards really refocusing metrology as a driver of economic development.
I mean, I just mentioned in terms of environmental aspects. So the government of India has very stiff targets which they have announced, committed to the global community. For example, by 2030, 50% of the energy is supposed to come from non-fossil fuel based generation. So there is about 50 gigawatt of installations of solar cell, solar panels in the country per year, right? So these are stiff targets in which the government is pushing really hard to the industry. So as NMI, we look at supporting these initiatives. So for example, we have set up the solar cell calibration facility, and we have environmental monitoring equipment certification scheme, which is Asia's first in India recently. So we have, we map the noise, around cities. We contribute to the metro constructions and other things, so for noise mapping and how to improve the noise mitigation, basically. So these are some initiatives which we carry out. So for example, water, I mentioned about Clean Ganga project. So in that, so basically we need water CRMs, the certified reference materials for water purity testing and other things. So we actively do with private partners, reference material producers. So we try and contribute as much to the environmental initiatives of the government of India, so that we provide the backbone for the government to deliver on its commitments.
So regardless of whether we're talking about the impact of climate change or changes in technology, Pascal, what's your take on how difficult or not it is to marry metrology's principles and practice in a world that's changing pretty quickly?
Yeah, it's not always so easy. I could give an example. In UTC, it was decided in 1971, when UTC was defined, that UTC should be in agreement with the Earth clock, so the time scale based on the Earth rotation, which is UT1. But UT1 is not completely stable because the Earth's rotation rate is sometimes higher or slower. And so it was decided to add leap seconds in UTC to be in agreement with UT1, the Earth's rotation. Essentially because there was still at that time a need for celestial navigation, so UTC had to be in agreement with UT1, and that is less and less the case because now we have satellite navigation which is available everywhere. And in addition to that, this leap second create a lot of problems in this changing world based on computers, digital clocks, digital systems, who have to manage sometimes 1 minute of 61 seconds, which is really complex. So different systems will put in place different ad hoc techniques to manage deep leap seconds. That means that during a leap second, or around a leap second, we can have errors of synchronization up to half a second, which is huge. And leap second occurs at UTC 0, so midnight UTC, which is the night in Europe, but it's during the day in Asia or in West America. So it creates a lot of problem, but even with that, so we have proposed, of course, the timing community has proposed to stop the leap second because of the risk for all critical infrastructure. We have examples of real problems. There were airline companies where they had all flight delayed because there was a crash in the software, and thousands of passengers had to stay on the ground during several hours. Then there was radio communications problems somewhere and so on. So really there is a risk for critical infrastructure, and even with that, it's more than 20 years ago that we are trying to stop the leap second. So it's difficult because it's probably people have always difficulty to change. And there is not only scientists in the debate, but also politicians or people from the policy works. And so that can take some time. So now I can ensure that at the latest in 2035, we will stop this leap second. But yeah, it's a process that was not so easy, and we are still fighting to try to stop it as soon as possible.
Thank you so much, Pascal. So you sent out there that it's really important not to forget the social context within which all of this is happening. And Willy, you were talking about how the CCQM initially really made it a goal to make sure that it was achieving some kind of social good. How hard is that? So you work, in one hand, you're working hard to align with the scientific community, but is the work that you're doing something that, a layman like me might care about? And is that even important to what you're doing?
I'm going to answer your question in a bizarre way.
Excellent.
I worked at NIST for 45 years. I never woke up one day saying, blank, I got to go to work. Because I knew that what we were doing had meaning, both to me, but also meaning to the greater society. So I could not have asked for anything more. I worked there 45 years, and less than 26 days over 45 years, which meant I went to work because when I was sick, but I enjoyed what I was doing enough that it was worth it to me. Maybe that wasn't what you were expecting, but that's how I'd answer your question.
It's still a lovely insight, so don't second guess yourself.
And also, I can extend that to the metrology community. Also, I could see the impact of work that we were doing. And you can't put a price on that.
Thank you so much, Willy. Pascal, so one of the things that crops up that I thought was super interesting, that I think maybe kind of links to what Willie has just highlighted, is that you think that following user needs is super important in terms of dictating what direction metrology goes into. What do you think metrology can do better in terms of reaching out to key industries or communities or even other scientific disciplines that, so that they can be in a better position to understand and offer solutions to potential problems?
Yeah, I think that certainly we have to go out of our community and to inform the stakeholders, the users, to educate them also, because they have to apply the metrology in their different fields, on the industry. We have examples in the telecommunication when they claim traceability to UTC. Sometimes they do not realize what is behind the word traceability, what they have to do to show, to demonstrate the traceability. And so that is the metrological community that has to explain and to educate the people so that they can also go further in their development and their performances, indeed.
Thank you. Dr. Ortiz, so how do you think that the moves to make it easier for countries to associate with the BIPM without full membership might affect the work that metrology focuses on, and also the benefit that other countries currently within the fold might be able to get from the existing official community?
Thank you very much. I think one area is, as we talked about, democratizing measurements and making it available. I know we have the 5 full members and 7 associates. What about the rest in a continent of 55 plus countries? So it means they are not actively members of the Metre Convention. But I think the initiative by BIPM to create another category would really benefit, because it means that they can be able to participate in some of the activities and be able to be part of the community that really works on measurements. Because in any case, we are all trading. We trade with these people. And so it's in our interest to make sure that they are also improving their measurement systems. And I think, as I mentioned earlier, with the African Continental Free Trade Area, where we're trying to open up markets, free access of goods. So it's very important that these countries can be able to have systems, can be able to have measurements which are, can be reliable, and also it can also improve the recognition of those measurements and facilitate trade. So it's very important that the initiative that has been done by BIPM to create that category where these countries who are not yet full members can be able to actively participate also in some of the measurement activities. Yeah.
Thank you so much. And in a bit of a trick, I think we're kind of going back on this, but I think it's super fascinating creating this, because throughout the day, on this panel and its previous panels, we've constantly heard concern or just flagging that more has to be done to communicate the value of metrology in the right places. There was a very guilty moment when one of the speakers earlier today said that, yes, anyway, it was one of the speeches about the history of the science. Now, I am a layman, and when I heard it described as being banal, after having spent so much time with people being so generous, speaking so passionately about something that has been so invisible for so many of us, holding things together, I felt a bit guilty. So, when it comes to helping metrology not only solve its own problems, but take up more space in the toolkit that we have in shaping our societies, do you think it is for metrology to do the pushing? And are the answers within metrology or the answers within wider society? Dr. von Siemens.
Oh, wow.
Chicken and egg.
Well, I think there's one word coming to my mind, and that's education. Specifically STEM education. So there is, if you look at the development of science and technology, it goes in something like that curve. If you look at the development of education, it also goes in that kind of a curve, but it is lagging. And while education is lagging behind technology and science, we see poverty. We see the bad times of the Industrial Revolution. Once people came up with the idea of school, where young children could learn the most important competencies they needed for this new age, then we come to a phase of social prosperity. And I think the same happens now. So, technology and science, metrology is advanced, and somehow people don't really know, and somehow people don't really know how to apply. So, if we bring that to education, and now I'm really taking the perspective of the young ones, continents with large young populations, we need to take this perspective of the young ones, and if we integrate them, then we're going back to this promise of the better life, that this is there. And I very much believe STEM education has an incredible power of bringing great people, resilient, great people into this field, and keep up the dialogue about the benefits that it can have. So, education.
Thank you very much, Dr. Van Siemens. Please, Willie.
I agree 300%. Certainly, we can talk about the impact of metrology on industrial productivity. We've been doing that forever. For the new generation, many of them have these ideals about improving the quality of life, and we can give lots of examples. Certainly, we do that in the chemistry and biology area. That's how we push it. Its impact on industrial productivity, but also its impact on the quality of life. And I've given talks around the world on that, and it always resonates when you give examples about the impact of metrology on the quality of lives.
Thank you so much. We've pretty much run out of time, but before I wrap up, I'd just like to whiz round very quickly our panel with just one final thought. Dr. Otich, please.
Good. Mine is just to urge the metrology community to continue in the same spirit, to work together, get the young metrologists on board, and open your doors. And not only your doors for us to come in, but also set out and visit those NMIs which are still lacking behind, so that you can also experience and see opportunities to support them. Thank you.
I've said enough. I'll just say it's so wonderful to be here hanging out with you guys.
So I just would like to reinforce your message. I think education is really important, and also going hand by hand with the user, the stakeholders, to understand their needs and to help them realizing their metrological needs. I think it's very important. Thank you.
Yeah, I mean, as scientists, we all do high precision measurements, but metrology here, we talk about the high precision measurements for quality infrastructure. So for that, the only way forward is we work together, as we have been doing. We hold each other's back, and where possible, push each other to achieve greater heights.
Embrace complexity and help the ones that are not part of this great community here to also embrace complexity. This world needs data-driven, knowledge-based science. And we need you. We need people in this room. Thanks.
Thank you immeasurably to my panel, Dr. von Siemens, Professor Gopal, Dr. Dufresne, Professor May, Dr. Rotich. It has been such a pleasure. Thank you all very much for staying with us for today. Let's give our panel a round of applause. So I'll invite you to go get comfortable in the audience. We're pretty much at the end of today's program, but we are lucky enough to have a few more words from some very esteemed figures from the international metrology community. It is my pleasure to invite up Dr. Takashi Usuda for the first half of our closing remarks. Please do join us, Dr. Usuda.
Excellencies, distinguished guests, ladies and gentlemen, colleagues, it is my great honor to deliver the closing notes. First and foremost, I would like to express my heartfelt thanks to all of you who have gathered here from across the globe, and to those who have joined us online. I want to convey my sincere appreciation to all the distinguished speakers and panelists for sharing their deep insights and forward-looking perspectives. I would also like to thank UNESCO for hosting us today, and we look forward to further contributions from the global metrology community to the International Decade of Science for Sustainable Development. Today has provided a profound opportunity to reflect on a century and a half of remarkable progress in metrology, and more importantly, to envision the next 50, even 100 more years of global cooperation. Let us take a moment to honor and express our deepest respect to all those metrologists, policymakers, and government officials who have contributed over generations to the success of the Metre Convention. I would also like to express my gratitude to the BIPM staff, both past and present, for their invaluable contributions. Where are the BIPM staff? Retired and active? I can't. Over there? Second floor, yes. Let us express our gratitude for them. Thank you for your warm hands. And to those who will join the BIPM in the future, we look to you with hope and confidence to carry this vital work forward. Thanks to these collective efforts, humanity now shares a common language, the International System of Units, the SI, and common timescale, the UTC. This is not only a triumph of scientific endeavor, but also a shining example of what international cooperation can accomplish. And yet, our work is far from finished. In a world that is rapidly evolving, facing environmental crisis, public health threats, and the urgent need for sustainable development, reliable measurement remains a cornerstone of trust. To meet these global challenges, we must continue to collaborate under the framework of the Metre Convention. The founding spirit of the metric system, measurement for all times, for all peoples, has never been more relevant. Today's celebration has reaffirmed the power of metrology for the better future of all humanity. With this, I conclude my notes in tribute to all who have brought us to this moment, and in hope for what we will build together in the years to come. Thank you very much for your attention.
Thank you so much, Dr. Asuda. And for the very final word, I now invite to the stage Ms. Amal Kazri, Chief of the Basic Sciences Research, Innovation and Engineering Section at UNESCO.
Thank you very much. Excellencies, distinguished guests, members of the metrology community, ladies and gentlemen. As we come to the close of this inspiring day, I am filled with deep gratitude and reflection. Today, we marked 150 years since the Metre Convention, a landmark in scientific history. But what we truly celebrated was not just a historical milestone. It was the enduring power of metrology to unite, to guide, and to serve humanity in an increasingly complex world. This event has reminded us that measurement is far more than a technical tool. It is the invisible backbone of trust in science, in trade, in health, in digital systems, and in climate action. And as we look ahead, it is clear that the future of metrology must be just as ambitious, inclusive, and resilient as the challenges we face. From the role of metrology in enabling quantum technologies to the importance in climate adaptation and digital transformation, we heard the three key messages today. The first is that precision in measurement is the cornerstone of global progress in innovation. And the second is that international collaboration in metrology is essential for tackling today's challenges and achieving sustainable development goals. And the third is accurate measurements empower nations to drive innovation and to enhance the quality of life of their citizens. We also heard a strong and common call. The global cooperation, equitable access, and inclusive innovation must shape the next era of measurements. And this aligns powerfully with the frameworks that guide our collective vision, the International Decade of Sciences for Sustainable Development and the International Year of Quantum Science and Technology. These are not just commemorations, they are calls to action, calls to ensure that science serves everyone and everywhere, and that institutions like ours lead with courage, integrity, and purpose. Allow me now to sincerely thank our valued partners at BIPM for their unwavering collaboration, and to all the speakers and the participants who brought energy, insight, and ambition to this gathering. I would also like to express my heartfelt appreciation to the incredible team at UNESCO. I will mention some names, but there are many others behind the scenes. Bashak, Ashwini, Atu, and Yuslam, and many others, all the RIA team, actually all the science sector team, and all the colleagues behind the scenes. Your professionalism and commitment made this event seamless and meaningful. Thank you also to the interpreters and to the technical team. For all the CLD colleagues for their essential work. Let us leave here not only proud of 150 years of metrology, but inspired to shape the next century with openness, collaboration, and shared sense of responsibility. Thank you very much.
Thank you so much, Ms. Kazri. I'm taking a bit of a risk before we wrap up, just to share a little something that just occurred to me. So I grew up in the UK, and my French husband, occasionally, I'll be like, oh, particularly when you're talking about height, he's like, 6'4". And he always says something like, I'm sorry, I don't understand what you're saying. Like seven furlongs of a wombat's tail, what does that mean? And we all laugh. But I've just started looking at that little moment of domestic misalignment very differently, multiplying it by the billions of people who have been able to be brought together, by the hundreds of years, 150, but the thinking behind it that came before that allows us to get stuff done. That saying of, if you want to go fast, go alone. If you want to go far, go together. It's actually, I don't think it's very right, because going alone is very inefficient. The Metre Convention is quite fantastic. It has allowed us to do things that we would never have been able to do. So happy World Metrology Day. Thank you so much for everyone who has guided us today with their knowledge and their inspiration and their vision, and all of you who've joined us today in the audience. And thank you so much for letting me be part of it. I have learned so much. You've got an ambassador. I'm out there telling people metrology's cool and to measure everything with appreciation. Before we leave, we're going to indulge in a little bit more of the beautiful music of Malik Dior and Abdou Koyate. Thank you very much for being here. Enjoy the next few days of the celebration. Do note that tomorrow will be at Versailles and not here, so don't turn up at the wrong place. Okay, thank you very much. Please.
So baba, manini kay lodi kay kumukunan, manini yena, logi siena, so do mama, logi siena, so do mama, logi siena. Logi siena, logi siena, logi siena, logi siena, logi siena, logi siena. Lo quisiera, lo quisiera.
Thank you.
suma déggulee semaine moom woma suma déggulee 2 semaines moom woma toge ba mat mu weddi ku ma mu commencé jaaxle ba tax sama doom ji moom mi ngi si jàmm ay Bachek, on te remercie. Oh Adou, on vous remercie. Aïe, baba. Aïe, baba, aïe, baba. Aïe, baba. Eh, mama, mama, oh, mama, mama, yeah, mama, mama, oh, mama, mama, yeah, mama, mama, oh, mama, mama, yeah, mama. Gracias, thank you very much. Suma découlé semaine, mon woman. Suma découlé 2 semaines, mon woman. Toge ba mat wetti kuma mu pensé jamne. Ba das la mat. Easy jamma. Merci à tous. Merci à Paché. Merci à tous. Merci à Paché. Merci. On est là. Merci pour la bonne organisation. Ah, merci à tous. Ah, merci à Bachar. Avec l'UNESCO, avec ATO, avec l'UNESCO, avec Bachet.
UNESCO, UNESCO, UNESCO, UNESCO, UNESCO, UNESCO, UNESCO, UNESCO. Merci.
Merci aux techniciens aussi, merci à tout le monde.